I've now started the recording. Thank you to all who've just joined. I'm going to mute participants on entry and we'll be started in a minute.
All right, so should we get started with the show? So welcome everyone. My name is Martin Brunskov. I'm the coordinator of NGIoT, Next Generation IoT, the support action responsible for producing an IoT roadmap suggestion for Europe. And today we have a thematic workshop focusing on energy. So welcome everyone. Just a little bit of housekeeping and introduction here. So as Catherine, our host here, said, we will be recording this, so please be noted and take your measures if you want. Please mute yourself, and that means both audio and video when you're not speaking or taking active part as a session. It's much easier to keep the focus this way. Please use the chat actively. We can be quite interactive when we are not more people than we are in these thematic workshops. And well, you can always raise your hand or put in the chat if you have a comment, and we will take these comments as part of the panel roundups which are placed throughout the program. And if you have any technical issues, I mean, if you can, use the chat. If not, feel free to use the email address on the website. Our moderator for today is Natalie Samovic. I'll just do the intros here together with the colleagues, and I'll hand over the floor. But thank you for being with us, Natalie of InnoQ team, as well as the Alliance for IoT Innovation. Good to see you, black and white. So first, to set the context a little bit for the work that we're doing here, allow me together with colleagues Svet Mihailov and Giorgio Micheletti to give a few introductory remarks. So as said, I'm Martin Brunskov from Aarhus University. I'll give you a short overview of what the NGIoT support action here is doing in relation to the roadmap and to the upcoming work programs on the European level. Svet will give you the policy context for this, and Giorgio from our sister coordination action called Open DEI about digitizing European industry, which relates to IoT but isn't entirely about IoT, will give the context from that vast portfolio of actions that are happening on the European level there. So first, just to be very simplistic about this, so NGIoT, the next generation Internet of Things, is an action which has been set up in the Horizon 2020 work program by the European Commission to ensure that there is a road mapping and mobilization of the ecosystems around IoT going into the upcoming work program, so Horizon Europe, and we have seen the text, it is not formally announced yet, as well as Digital Europe program and many more, such as the Digital Decade, Compass, and so on. And we have been working for almost 3 years, so we have half a year or so left of this effort, and we will deliver this roadmap for IoT research, innovation, and deployment to feed into the upcoming work program texts. So that would not include the 2021 and 22 Horizon Europe and so on work programs, because they have also already been finalized. No, but this is feeding into the midterm, so what is coming on the horizon next, so in 23 and 24, and of course everything else that relates. And what we have been doing is that we have been taking input from the community and basically other strategic research innovation agendas. This is also why we are very happy to be co-organizing these sessions together with organizations such as the Alliance for IoT Innovation, Artemisia, and others. Consolidating now this input and always being aware of the dynamism that exists in the global market of technology and the the dynamic nature of this research, innovation, deployment space. We are now putting this into a more condensed and concise format. So, of course, the overall objectives is, as always, to give EU a reflective and reflected position on this to support the priorities of the European Union, including the competitiveness, but also to support whatever strategic goals the EU will have, including, of course, climate neutrality. It's a big thing, together with, of course, the cohesion policies, so that there is no one left behind, and that's the triple baseline, you could say, always observed. And then, of course, to understand what the digital transition means, and in particular in the IoT edge cloud continuum, with high performance computing and data centers in one end, and the far edge with little devices with very limited capabilities. How do we understand that spectrum and the layers that are involved, as well as the societal and economic implications? So yeah, there's a lot of landscaping that has been going on. You can see it in what is presented on the event website even for today. And today, of course, we will dive into the energy. And by the way, if you want, after lunch, there is the similar deep dive into health and care. So you see, it's not something which is starting today, and several of you have been with us before. So it's a great pleasure to focus in here. So we see some clear trends. I'm not going to go into the details, but what's coming out in a white paper that we're producing as the draft interim stepping stone towards the roadmap, which will be delivered after summer. We clearly see, that the centralized view is diversifying, let's say, and whereas data has been very much, just going to the cloud, now there is a move to understanding the potential and influence of the edge, and of course the analytics and everything that's going on there, and ultimately understanding the governance and value flows that are around these edgified infrastructures that we are seeing. So there's a lot of known stuff here, and I'm sure our colleagues, both in the introduction as well as those who will do their interventions as part of the topical sessions, will unfold these. So that's it from my side. I give the floor to Svet Mihailov. Please, Svet, introduce yourself and also take the floor. I will stop sharing the screen so that you can take it. Yes, over to you.
Yeah, just want to activate that. Share the screen.
So far, we see you.
Yes, I know. Just with all these tools, one has to switch.
Yes, and now we see the screen. Still needs full screen mode, though.
Do you see it now well, or?
I think it's coming. I don't see the full screen yet. Now I see it. There's a gray bar somewhere in the middle. I don't know if that's part of the tools, if there's a window that can be, so below the European Commission logo, there's a gray box. I don't know if there's something on your screen that can be moved.
Ah, you mean, okay, this is the, these are the speakers. And
okay, maybe just get rid of everything. Perfect.
Yeah.
Don't touch anything. We see it perfectly.
Apart from the up-down buttons.
Yes, and you. Very good. You have the floor.
So I'll be mentioning some things about digitalization of energy in respect to what you already mentioned, what the topic is here, the Internet of Things, the cloud continuum, the energy data space, and so on and so on. Yes, my name is Svet Mihailov. I'm from Team E4, Internet of Things at DG Connected, the European Commission. I'll be going quickly through the slides, just presenting some of the things, of course, some were presented by Martin, some were presented, many of them by Rolf in the previous workshops and probably in the next one as well, etc. But just to kind of go quickly through them to present the background and the Commission vision of it. So the digitalization of energy has been coming for a long time. There have been the evolution of the digital space, such as, microelectronics, software, 5G, leading to more advanced digital technologies such as robotics, artificial intelligence, big data, cloud, which we'll be talking more about, blockchain, etc., Internet of Things. And then the evolution on the energy side, such as decentralization, demand response, more renewables, electric vehicle charging, and so on, prosumers, etc. And then there are the European strategic goals, such as the Commission, like the European Green Deal, the Europe Fit for Digital Age. So this has been happening for a while. These are new goals and targets, but we have been working on this for more than a decade, at least, if not more. What is new is what we're talking about today, and in general recently, is this paradigm shift from the cloud towards the edge. Already the cloud was kind of a new development within digitalization of energy, but then now we are going towards move to the edge, and IoT is very interlinked into this whole move and the new structure of and digitalizing of the energy system. And this forms the cloud, edge, and the IoT that form this compute continuum that we need in order to advance to the next generation of Internet of Things, digital services, but more particularly in the energy field as well. We have in this trend, in this shift, we have the compute resources and also all the other processing, such as artificial intelligence, etc., closer to the data where it is generated. And when I say closer, it can be the edge, cloud, or whatever you call it, which will be kind of a tiny data center close to a factory, close to the road, close to a building, etc., in a residential area. But it could move even in a car if you want to, or in a tractor as shown. But you can go even further into a kind of a far edge, which is really a device, here a camera, a thermostat, whatever, where it can be close. So, of course, it has different level of compute capacities, etc. But it can go as far as, and then we're talking about swarm computing and all these things. And what we're trying to do is to federate these edge resources because, yes, they are distributed. Yes, they make sense on their own in a certain device, certain tiny data center or edge node. But they have to be federated in order to produce, among other things, also the European Common Data Space for energy, for example, or other areas. When we're moving towards this edge, we see new opportunities for the European industry because if we go into the cloud, the big cloud, we know who the big players are. We know the Amazons, the Microsofts, and the Alibabas, etc. We know them. They're not European. So we see an opportunity moving towards the edge and the far edge opportunity for the European players. And also what is important is that this edge, being close to the application itself, should be customized towards this application. So in the case of energy application, it should be customized and it makes sense to be customized and it will be way more optimal done that way. This is just a kind of a commercial way of presenting some of the advantages of moving towards the edge. I mean, the way lower delay and latency, jitter, etc., that is happening. Here, of course, it's shown a user browsing on a bench, maybe 11, 12 milliseconds is super fast for this user. But of course, as you know, when we go into mobility, energy, and other applications, we want even the 1 millisecond, a sub 1 millisecond delay in order to have it viable. It is the use cases that underpin these trends from the move from edge to far towards the edge and then from the edge to the far edge. And the use cases, they of course depend on the different areas. There are use cases in mobility, there are use cases in agriculture, and there are use cases in energy, which of course these use cases, without listing them, they are targeting things such as achieving the targets of 2030 and 2050 for greenhouse gas emissions, efficiency, renewable energy. They enable new market roles with this digitalized system, new market participants, energy communities, new digital solution services, et cetera, the participation of the consumer, and so on. By addressing this on a holistic level, of course, we can optimize the resources that are available, the storage, the network, the computing centers. And here I have visualized something that we've been repeating over and over again. I think we're not the only ones. I mean, we have heard it from the whole industry, the whole society, that from current 80% computing resources based in the cloud and 20 maybe in small objects in the edge, who in a matter of 5 years or so will be moving to exactly the reverse situation where 80% will be at the edge and 20% will be centralized. The Commission, among other strategies, has developed the European Data Strategy, and among its, there are several actions that we've foreseen, but among them, some that I would like to highlight here is actions linked to the cloud, and where we have a European Industrial Data and Cloud Alliance, and then actions linked to the data spaces. So these European Common Data Spaces that will be per area. Of course, they're working, they'll be based on the same principles, but they'll be on different areas. And then, of course, there are the other movements of the member states and industry, etc., such as, for example, the Gaiax that is shown here, that is addressing the same problematic on a more practical level. And they're also putting efforts and financing into this. So we are working in unison with the member states and industry and the whole society to achieve this coordinating among all these data initiatives and actions. As I mentioned, these data spaces are in a number of areas, and in the communication that the Commission made these areas were named, or at least the initial set of areas was named. And energy was among the initial set that was mentioned. Although when building now within the Digital Europe program, which is the program that will be the main program that will be addressing these data spaces, creation of these data spaces. In the first work program, it's not there, but it's almost certain that will be there in the second work program without committing on this. And these data spaces will be going hand in hand with the development of cloud and edge. And this cloud and edge has also been addressed, the deployment of it, infrastructure, the service, etc., the marketplace for services, if you want to. They have been foreseen and addressed already in the first work programs, in the Digital Europe program, in the Connected Europe facilities, and of course in the national plans of the RRFs and the IPSA instrument. All of this address the creation of a European cloud edge continuum that will be competitive enough with the global players and with the very adapted to the future needs of the different verticals and industries. And they'll be defining high-value data sets that will be made available throughout Europe in a standardized way and accessible and easy to obtain way. There are several slides here explaining, again, I mean, I'm not going to spend too much time of it, but again, we're talking about incorporating more renewables that I mentioned already, the flexibility of the grid, its maintenance, its operations, the connectivity of the system, etc. Of course, not forgetting security and so on. Similar here, there is, just to name one, but of course there are others, but one of our projects, large-scale projects on Internet of Things, that is exactly addressing an energy use case, which is the interconnection between the grid and the home in order to optimize the use of renewables, the energy efficiency, and so on and so on. So enabling demand-side flexibility and demand response. And again, I mean, this is about decentralization, intelligence of the far edge, etc., etc. This is not, like I said, the center is to a great extent the home, where we are trying to see how the appliances, the energy management system, the smart meter, the wall box, you know, the EV charging station, how they're interworking, how they can contribute together into optimizing the energy usage and the grid. And this is not something new. I just wanted to mention some developments that we did over the years. For example, the SAREF ontology. And here, what I've shown concretely is one initiative, a study that we had of demand-side flexibility, where we aligned all the standards, because SAREF is one of the standards within the home, one of the ontology, but we aligned all the standards that are going all the way from the producer, from the utility, from the energy services company, all the way to the appliance within the home, or EV charging, wall box, etc. How they can interwork for the most common use cases. And then they were aligned, adjustments were made, and it worked. And we demonstrated it on several big events. And this demo that you see is within the European Commission, but we also had it at the European Utility Week, at IoT Week, etc., etc. So interoperability is there. We have been working on it for a while in respect to standards. Of course, building up the edge capacity is what we are aiming at now, and greater penetration of these standards within the industry. And in the case of SAREF, as you see here, a number of companies within e-bus and energy at home, etc., have implemented it under the name of SPINE in commercial products. Again, I already mentioned some things that will be addressed in the upcoming programs within. As Martin said, not everything is fixed in stone, but close to. For the next programs of the Commission. So let me mention something that is without committing to 100%, but maybe 80%, I don't know, to it. In the Digital Europe program, there are the sectoral data spaces, which, as I said, at this stage, the data space is not yet in this work program, but it's coming from almost sure the next one. There is cloud to edge infrastructure and services that we already mentioned the building of it. Then the testing experimentation facilities for artificial intelligence in verticals. And because we're talking about energy, there will be energy use cases in the communities testing experimentation facilities. And also there will be pilots of energy services within communities. In Connected Europe facilities, we have the rollout of 5G corridors and then operational digital platforms which are focused on the energy area and transport. Then we have the recovery resilience facilities where we have the member states' investment into infrastructure, multi-country projects, and so on. And in Horizon Europe, there is the joint undertaking on smart networks and services, the joint undertaking on key digital technologies. There's the partnership on AI, data, and robotics, and some things that are more dedicated to the topic today that we are very involved in. It's on one side, in cluster 5, the replicable solutions, interoperability, energy data space. So although it's not addressed in the Digital Europe program, it will be started already, the preparation of it within Horizon Europe. And also we're going to be working again on this kind of minimum interoperability mechanism, if you want to, within the energy area. And some other supporting actions. And then there is within cluster 4, the digital cluster, dedicated research initiatives on cloud to edge to IoT. And in this respect, just maybe again to draw your attention, because it might be of interest to you, this last call that I mentioned, it will be creating European platform for the edge, so to say, where all these different devices of speech recognition, thermostats, as you see, and other cameras, if you want to, will be connected to this platform in order to improve end-to-end response time, optimize operational IoT system and services. Meta operating system for the edge will be this platform. Of course, we'll be aiming at reducing energy consumption via keeping the data at the edge and other tools, and then orchestration across device, cloud, and edge. And the pre-publication, you can see the link, so you're most welcome to get involved in these projects. We'll be very happy if you do so. So these are some of the things that I wanted to say. We don't have time for more, and I think I'll be adding a lot to what the other speakers will be saying, because the things are well known. Thank you.
Thank you so much, Svet, for this concise overview. And I think, well, the technology part for sure, just so that we are on the same page, but also how this relates to the various instruments, as you say. There are many, and they are new, and we are still getting acquainted with them. So it's good to see that there is this kind of relation between the different ones. So for Horizon and DEP, and these new instruments where technological priorities can be really fast-tracked and now invested in, also with public money, without violating the subsidizing and competition regulation. So it's an interesting space, and it's good to have recurring events where we understand more and more who's doing what. So I'm now going to pass the floor to Giorgio. I hope you're with us. I see you in the list, representing OpenDEI and also Polyme. So thank you for being with us and for giving your view very much from, I wouldn't say the ground, but also, from the baseline that we're operating from, all the projects, all the actions that are going on. So I'm going to give you the floor, Giorgio, and please give a quick introduction to yourself and OpenDEI. I hope you can take the screen. I actually do not hear you. I don't know.
No, we don't hear you, Giorgio, and you're not on mute. So there seems to be an audio issue. And I see you on the call twice. This might be one reason why we can't hear you. No.
So do you want to reconnect, Giorgio, just to see if there's anything, or do you want to pull out the hardware for a manual override? Okay, so I think Giorgio is reconnecting. So in the meanwhile, I will just pull up here so that everyone can see. So just have everyone's eyes on the program. So of course you have seen this on the website. Maybe if you want, there's a little bit of reading, if you haven't already. I mean, obviously there's the Alliance for IoT Innovation white paper. Natalie, you will be going into that later today. There's also a couple of white papers from Siemens and colleagues. So I think what we're doing here is we are not trying to reinvent the wheel, but really to establish, as I said when introducing Giorgio, a baseline where we can work from. So like with OpenDI, it's very good that no, Giorgio, we're not hearing you. I don't know if we can. Okay, just a second. But like we have, I want to draw. Oh, we can hear you now. Actually, I think.
Can you hear now?
Yes. Just to say that. Please.
Yeah, sorry.
Actually,
I need to wait for my.
Okay.
Change this. Can you hear me?
Okay, but this is very good, actually. I'll just finish my sentence and you get the floor. So just to say that what we're doing here is we're not just, starting from an individual case basis. We are really working with those people who have done strategic work here. So like I said, the Alliance and OpenDI and Bridge, we will hear later. And it's a great pleasure then also to introduce you, Giorgio, because you have been in this space and also before OpenDI, you've been working really on establishing the baselines, not just for IoT, but very much related to IoT. Right? So I give you the floor now. I hope you can share the screen as well.
Yeah, thank you very much, Martin. And I'm sorry about this technical inconvenience. I have very old headsets and need to change that. So first of all, thank you for having me here, and thank you for everyone who's joining, and thank you personally, Martin, for this invitation. I'm here actually to spend a few minutes, and I understand we are already behind schedule. I think we are already quite late, so I just wanted to present a couple of slides. Let me see if I can share my screen. Essentially, I wanted to introduce a couple of concepts of what OpenDI is doing. So the project is one of the three CSAs that are working in this environment, in the IT environment, among others, and belonging to the E4 unit of DG Connect. So a short introduction of what we do, and then I'll leave it actually during the day to some of my colleagues, in particular Alberto Donini, who is taking care specifically on our activities in the energy domain. So let me see if I can share the screen. 1 second.
It should appear at the bottom of your screen.
Yeah, I'm checking.
It's between next to the chat.
Yeah.
Great, thank you.
You got it? Can you see?
We see it. You just need to switch to presenter mode on your PowerPoint.
Yeah.
Brilliant, got it.
Thank you very much. So basically, just a few words on what we're doing and who we are, and I'm not going through all of this. I think we are already a bit late. So essentially, OpenDI is a CSA that was launched in summer 2019. So we are already past the half of the projects. We have 10 partners, and so we've got partners who are more technical in their remits, and we have partners that are specifically devoted to 4 specific domains in which we operate. We've got the energy domain, and is represented by the University of Aachen. and we'll have a presentation shortly from them. But we also have partners representing the manufacturing sector, the energy, the healthcare sector, and the food and agricultural sector. Now, this is to stress the fact that OpenBI is actually moving around these 4 different areas, which we call domains, and we have partners that are called ambassadors in this respect. So they are essentially building an ecosystem of projects around these specific sectors. And I'm not going down this slide, but I'd like to spend just a few seconds on this one, because what is OpenBI doing in this ecosystem? So we have defined a methodology to reach out to the right stakeholders in these domains. So this is obviously valuable also for the energy sector. So first of all, as I said, we have appointed specific partners who are responsible for these domains and have a specific knowledge for these domains. We have defined the ecosystem in the sense that they've been going out there and see which projects are actually those that operate in our remit of platforms. We're not dedicated only to IoT, as Martin said. I've been and we have been involved in the IoT, but OpenBI is a more transversal and horizontal project in this respect. And then we have defined a series of tools to interact with these projects. So we have defined working groups with them. We have defined other supporting tools in terms of events, webinars, and regular meetings with them. We have carried out the activities of the working groups, and we also have decided, and this is a specific plus, I think, of OpenBI, we have defined cross-domain activities. So we have realized that some of the themes that are valid for one specific domain are actually representing themselves in other domains, and therefore we have launched the concept of task forces, who are supposed to work around a specific topic, but not necessarily by industry sector, but also on horizontally on several industry sectors. So to give you an idea of the projects that we have identified and we have in our remit of the ecosystem. So here you've got the 4 different domains, agri-food, energy, manufacturing, and healthcare. We've got a number of projects in the so-called inner circle, so those that are directly related to our activities as an OpenBI. We've got projects that are more in an outer circle, therefore they are still related and still in those domains. And here's an example of the whole ecosystem as it stands now. So we have more than 35 ecosystem projects at the moment. And again, in a few minutes, we'll have something more on the energy domain, and we will have a presentation from 2 of these projects in the energy domain, so Interconnect and Platoon, that you see featured here on top of this slide on the energy sector. As I said, and I'm going to finish here, we have put forward a series of tools to interact with these projects and with the ecosystem. We've got the working group. This slide gives you an idea of which working groups have been established by domain. Some of them are similar in every domain. Some are specific to the domain. So here you can see on the right-hand side what's actually happening in the energy domain in terms of working groups. And also equally important is the concept of task forces. And as I said, task forces are cross-domain. We have 4 task forces, as you can see on data sharing spaces, on business ecosystem, digital platforms, and performance and benchmarking. The first one, so the digital transformation and data sharing spaces task forces has just released, or a few weeks ago, it's released a white paper. And the idea is actually to produce common tools or common outcomes. And the white paper has been very successful and very well received also by the European Commission. I think with this one, I'm finished. Yeah, I forgot to say, my name is George Micheletti, so I'm the coordinator of this project together with Sergio Guzmoli, who could not be with us today. So thank you very much, Martin, for the time that you have allowed to me. Thank you.
Thanks a lot, Georgia. And I think, and my apologies, I think I mixed up the affiliation. So you're from ITC,
yes,
and Sergio representing Polyme. My apologies.
No worries. No worries.
Okay, thanks for being with us and also for co-organizing this. I think it's very good that you know, both from the community side, but also that we as the coordinators of these specific things, so roadmap, baseline, learnings, and then the mobilization of the community, preparing for the upcoming engagement with the work programs. I think it's very important that we are not just aware of what each other do, but actually we work actively together. So very happy to have you here. Thank you.
And for this, I thank you again for this invitation, Martin. Thank you.
Fantastic. All right, and we will hear more about the work that you introduced here in the program. Right, so we're a little bit behind schedule, but do not worry, because we have a very efficient moderator, Natalie Samovic. No, but we have allowed enough time also to have a little bit of slack here. So I give you now the floor, Natalie. I can just show, if you want, here the presenters in the sort of payload session here on new concepts in Grid and Edge, and we will take them in two tranches with a little bit of discussion. So over to you, Natalie, and let me and Catherine know what kind of support that you would like. I will perhaps act a little bit as a discussant throughout and making the links to the NGIoT. Yeah. So over to you, Natalie, and thanks for taking the baton here.
Thank you so much, Martin. First of all, you can hear me and you can see me.
Yes.
And I can see the screen at the moment. Just first of all, thank you so much for the invitation. The most important part, I think, is the fact that there is a great continuation in the effort, both from the Commission side and as well as from the supporting organizations. This is great to see. We're not new to this exercise. Personally, I was involved for already a number of years in the marketplaces exercise, IoT marketplaces that we've started more than I think 3 years ago, and it's great to see the stages of the development. I think as Svet mentioned that we are focusing now on the intermediate period, and so just once again to stress out how important this continuation and the focus, and as well as the evolution on these topics. And I guess this evolution of these topics we will focus on today. Without further ado, we have two sessions. We have a little bit less than 2 hours for both of the sessions. The important topic is having enough time for discussion in between, which you don't see in the agenda, but that's something that we are very much looking forward to. So the two sessions consist of 2 parts. So the first part is where the organizations will introduce the strategic agendas and their positions related to the topics of the grid edge in energy and the related evolutions. And the second panel will focus also on additional concepts. And we have the discussion session in between. So for the purposes of speeding up a little bit, because we're a bit behind, I will introduce very briefly the panelists, the presenters, and if there is anything else you would like to add in your introduction, please feel free to do so. And we will try to keep, since we have 5 presenters in the first session, we will try to keep the presentations between 5, 7, 10 minutes max, so that there is enough space for discussion. And if you could be sharing your screen and getting ready with the presentation. So for the first session, I would like to ask Peter Hermans to start. Peter is former CTO of Stedin Connect, great experience in the energy sector, representing distribution system operator. And now on his new mission and getting engaged with the new topics in addition to the good old ones at Valkyrie, where he's a managing director. Peter, yes, I can see your screen, so thank you so much, and take the floor.
Okay, thank you very much. Actually, I feel very honored to be on the conference invited again after the conference of the 22nd of April. The workshop today is on energy, and it is a sector in which I've been working for more than 14 years now. So I know really what's going on there. And the topics I would like to address, you see here. First, IoT and Edge Computing. What does it really mean for the energy sector? Then some takeaways from the conference on the 22nd of April for those who did not attend there. Then certainly talk a little bit about what I see as ambition and needs as expressed by the European Commission. And then the fourth one, and maybe that brings us then later on in the panel discussion, how do we come from vision to action? And is there really a will to jointly go forward, and do we feel some sense of urgency here? First, some trends in the energy sector. I think it's no surprise that the Green Deal is the driving mission here. Massive decentralization of renewables is really driving intelligence to the edge. And actually, we are transforming to a complete new energy system. And this requires an integrated approach over energy carriers, electricity, heat, gas, but also on sectors and on governance. Actually, we are in the midst of a perfect storm where the energy transition meets digitalization. Intelligent at the edge means data at the edge. And this means that we also have to take into account data privacy. Commitment of the end customer is really crucial and successful for the energy transition. And trust on data collection and data processing is as well crucial. And commitment is built on trust. So the customer will need to be fully in control over his or her data, representing his or her role in the future energy system. Let me talk about what does it mean then for the energy system as well. First of all, it will be completely fully data-driven. And that means also that the energy system of the future will not be built on the silos of the past, a statement which I more times rephrase there. And that means here that we should get rid of the traditional discussion between data before or behind the smart meter, and that the energy sector also should cooperate with other sectors like automotive or the building sector. Because electric car will just be an important element in the energy system as well. This also means that we have to shift our focus from who holds the data and who has the database to who has access to the data. And this will require, I think, a new market neutral role for organizing and exchanging data. Actually, in the Netherlands, we are taking some steps in this already, as we are implementing a data exchange framework in the energy sector, which is actually supported already by the new National Dutch Energy Act. But we have still some homework to do in the energy sector, and that is how to translate unbundling to the digital space, how to govern digital twins of the energy system, and again, who has access to which data based on which services. And this all with system operations to remain as a neutral service. For me, it's clear that IoT and Edge Computing is a must for the Green Deal realization. And the energy system will require demand response, processing of real-time data, EV integration, multiple actors on one connection, new wide area protocols, etc. And this simply will not be possible without IoT and Edge Computing. And I said that also on the 22nd of April, I think it would be wise that the European Commission would send a strong signal to the member states that the next version of smart meters should not be anymore a smarter copy of the existing smart meter, but it really should be based on IoT and edge computing architectures. And actually this will require a European roadmap defining requirements and functionalities in a timeline up to 2030. And there the urgency is coming from. Intelligent in the edge, in the context of the whole energy system, I see a lot of technology discussions that talk also a little bit about market models. The energy transition drives us to an energy system in which millions of decentralized assets will contribute to the supply of energy and to the stability of the system via flexibility. And at the same time, we see blurring boundaries between the wholesale and retail markets as the end user or prosumer is becoming an active player in the market model. And IoT and edge computing is about sensoring and computing architectures and capabilities very close to physical assets. So it is important to identify these physical assets in the context of the whole energy system and its market model. And that is what you see depicted here. And as most of the capabilities in the market model today are already supported by cloud solutions, then it becomes also immediately clear where the opportunities lie for edge to cloud interaction via open interfaces or open marketplaces. And finally, where I talked about the unfinished job of unbundling, when we want to translate the unbundling to digital space, then this would also automatically identifies the APIs which need to be standardized within a cloud or a cloud edge computing interface. And if these APIs would be legally enforced, then this would define unbundling in the digital space and really enable openness in the continuum of the computing ecosystem. Some takeaways of the 22nd of April. I think it was a very good conference. I put here some remarks what I saw. It was really, I think everybody really saw a high potential and an increasing momentum in Europe for IoT and edge computing. I think the requirement on openness for edge and cloud to cloud was generally agreed. Then for me, it was overwhelming that there are a significant number of alliances, sector specific, but also cross-sector, were active in the field of IoT and edge computing. You see some logos here, but actually the story of Giorgio this morning showed me that this is far from complete. Then also the European Commission made, I think, a very strong statement. Only via collaboration we will be successful. So collaborate on platforms and standards and compete on solutions on top of it. I think that was what Max Lemke said. A very important issue there was, how do we incorporate trust, privacy and security, not in an edge computing device, but in the overall ecosystem. I think that's one of the major topics to address for the coming years. And to develop a data exchange orchestration, maybe first per sector, and then cross-domain orchestration across sectors on top of that in a federated way within a horizontal European framework. Otherwise, it would lead to strong fragmentations. And what I noticed that from the conference, certain sectors are very active: automotive, ICT, telecoms industry, and even consumer electronics. Other sectors which are needed for the Green Deal realization, well, they were not still that strong visible, including the energy sector itself, government, building sector, and agriculture. So then coming to the ambitions as what the European Commission expressed in that session, I think there are three types of additions we should address. First one is realizing the Green Deal objectives. End user commitment and engagement is important. Affordability, it's a big discussion coming on now on the Netherlands. We will have to pay the bill for this all. And affordability will immediately lead to, will we need demand response system integration and vehicle to grid integration to keep the cost controllable. Then from a digital perspective, well-functioning data markets, welfare for all citizens. And I refer to, well, it's not the winner takes all, where the big tech platforms take all the profit and the rest just have to look at it. And important data privacy ensured and cybersecurity. And the last one, I think, was also mentioned by the European Commission, European competitiveness in the IoT and Edge Computing industry, really leveraging Europeans' industry expertise, that the expertise is going into the edge computing, and not only in the cloud platforms from the big tech giants. This requires, to my opinion, that there needs to be a very strong coupling between the objectives, between cloud and edge activities which we're doing, really transparent, connected to the Green Deal mission. We need strong cross-sectoral collaboration. We need speed, really speed. If you see that the smart meters rolled out in 2012 to 2020, then I expect that about 2025, a lot of European countries will start to replace their smart meter for the next generation, the second, or some even for the third generation of smart meter. And I think that would be a missed chance if that would lead to just copying the existing smart meters, but a little bit more smarter. I think it requires openness in the digital ecosystem. So that creates standards, create markets. A topic which I see which is not well worked on yet is clear governance on data exchange. I think that's a missing part. And finally, public-private cooperation, and not only in Horizon 2020 projects, but also really going beyond projects. Bringing me to the next slide. Having reflected a little bit on this, and I saw it already back in some of the presentation which were early on. I think we should consider two types of working activities. I put it here in as working groups. One being working on use cases, different sectors participating, really representing the demand and defining and describing the first use cases. I learned that there are already use cases on the way, but also use cases which have the non-functional requirements on board, otherwise the platforms would not able to support them. To work on general principles for requirements and data sharing, like trust, privacy, security. As I said, not only sector specific, but also cross-sectoral, and at least for the Green Deal, the automotive, building, and the energy sector should be present. And the use cases should be input for a platform group. And then the platform group, that participants should come from all relevant alliances and should cooperate. I saw a lot of alliances. And they really should sketch a functional reference architecture, agnostic, as basis for solution architecture, provide input to the template for the use case, what needs to be in order to support these use cases. And after receiving the use cases, showing how these to implement in delivering a functional specification for solution platforms, including the standards to be used. And then this all should lead to well-defined use cases to be used by everyone in Europe, and a well-defined functional specification, technology agnostic again, including a set of standards for the platforms to be used and for the elaborated and future use cases. To my opinion, the European Commission should drive the process and be much more involved than only issuing goals and making budgets available in the Horizon Europe program. And I suggest that in the panel discussion, we discuss a little bit how we could come from vision to concrete action. Because as I said, if we want to take the opportunity for the next rollout of smart meters, then first releases should be ready for implementation for the energy sector by 2025. And this is the final slide I would like to show, just as my input for the panel discussion. Normally the audience asks questions to the panelists. Well, in this case, I reversed the thing. I said, well, we talk a lot about content and vision, but let's talk also a little bit about approach and how we join forces in here. What is the best approach? And then actually, is there willingness and commitment at stakeholders to contribute, sector experts for expressing the demands and needs, and cooperation between the alliances in setting up the specification of the platforms. And finally, what should be the role for the European Commission to ensure that really the envisaged results are timely achieved? Thank you.
Thank you so much. Peter. Lots of food for thought and concrete suggestions definitely to be discussed later in the session. Since we're running a bit late, so I would like to give floor immediately to Alberto Domini with OpenDI, who's managing the energy cluster in the OpenDI.
Yes, thank you very much, Natalie. I hope now you see my screen well with the OpenDI slide.
I do. Take it over, Alberto. Please keep in mind that we're still going to have a bit of time for during the discussion as well.
Yeah, definitely. No, I will not take so much time. I just want to give a short overview of the activities that we are carrying out in the energy domain, and as already presented by Giorgio Nicolet in the initial introduction about the OpenDI project itself. So I will be quickly going to the second slide. Okay. Yes, this is the ecosystem that we are working with. So indeed, we have selected and we are collaborating with several projects that are working with the main pillars of OpenDI. So with respect to data exchange with the architectures that we have in the energy domains. And around our ecosystem, we have also several entities that we are looking at to get inspiration and to provide content for our collaborations among the projects that we have. So here just to list some of them, like Bridge, Linux Foundation for Energy, Gaiax is already presented already this morning, ETIPSnet, and so on. Yes, so to talk a bit about one of the activities that we are doing right now is to start working with the use cases explorer, so to analyze the synergies among the different pilots that the projects that we have in the domain are carrying out. And to do so, we applied a methodology that has been proposed by the project Interconnect, which is about the design thinking methodology for the use cases. So the idea is to leverage on the creativity and to move for a human-centered perspective. So to analyze all the roles of the stakeholders in the pilots, to see how they can interact with the different users, which are the energy services that they are developing, and how are the market models being developed according to this creative problem solving. With the use of different experimentations, then you can completely specify entirely the pilot and the use case. And for this, we started with different pieces. At the moment, we started with the manifesto and the ecosystem, and we plan to move forward to have the complete overview of all the pilots of all the projects. Next, when we talk more about the data and the shared infrastructure, we have a different working group. And for this, we considered as a starting point the 9 building blocks that have been defined by InnoPay for the data exchange. And the goal here was to select which of these building blocks are mostly the focus of the project's activities, and where are the synergies among the different projects inside the domain, and also for a future expansion in the cross domain. So outside only the energy, but also with the other healthcare, manufacture, agriculture that we have in OpenDI. To do so, we started referencing to well-established architectures that are coming from other activities or projects in the European context. And then for some of the projects that we have in the working group, we decided to select which are the most important building blocks. And to do so, we arrived at focusing our attention to the business model, to the authorization, to the exchange protocol, and to the data standards. And with each of these, we could select which are the most relevant and most important achievements of each project that we have. To do so, we had been also able to select which are the most used solutions And these have been very useful also to identify the collaborations among the different projects. For example, identifying which are the communication protocols that they are exchanging and they have in common in their pilot activities. And yes, and the way is to expand this, as I said, also to the cross-domain point of view to see if possibility can arise. Yes, just to conclude, the next step that we took was to look not only at the 9 building blocks of InnoPay, but to take as a reference also the data exchange architecture that have been presented by Bridge. And this is starting from the SGAM architecture to move to a cross-domain approach. And also in this way, we applied it to our projects that we have in our ecosystem to see which are the solutions that they are using and how they are moving with respect to the different layers that we have in this architecture to identify again the synergies that they have. Yeah, to foster the collaboration. Yes, that's all from my side, just to give this short overview about OpenDI activities.
Thank you so much, Alberto. Just a very quick question, since we're a bit later on time. So Alberto, you'll participate in the dialogue session, so we'll save the questions till later. Thank you.
Thank you.
Just to check with the panelists later in the session with Antonella Monti and Pierre Gronlier, are you okay with a bit of a delay in the schedule, or would you like to go ahead with your presentations?
I'm fine on my side. Pierre Gronlier speaking.
Okay.
I can wait as well.
Okay, great, thank you. So then I will go with the AOTI presentation at the moment. Let me share the screen. Do you see my screen?
It looks perfect.
Yes, great, thank you so much. So very quickly, I'm representing European Alliance of IoT Innovation, and today for the session I will share the work that's been done linked to the publication of our latest paper on IoT marketplaces, data and services, specifically linked to energy sector, but also taking a lot of concepts related to the cross-domain sector into the consideration. AOTI has lots of domains under one roof, let's put it that way. So energy is one of those. And from that standpoint, we have a very fortunate position that we can bring both the buildings, the mobility aspects, the energy, the smart cities, and as well as more transversal topics together. So what you see on the screen is a title towards IoT data marketplaces as the reference model for the exchange between the smart transactions and shared governance. This is our vision for the intermediate program of what we currently have, and of course the key components here is the upcoming smart transactions and shared governance, which is of course not in place yet in the energy sector. So the first question is, where is the edge now? You see here the representation of the Vision 2050 that was done at TIPSNet, European Strategic Energy Technology Plan, and all of those components that you see are the representation of edge, and also deep edge, which is beyond that. So the system is complex, and it is this year, the past year, that TIPSNet released the paper on the smart sector integration, where from the get-go, the interface, this in response to the dual or twin transition was presented. in collaboration with a working group on digitalization in energy. So in response to that, we at the AUTI also took up the topic, and the smart sector integration beyond the electricity is also very much on the forefront of our thinking. So there are lots of initiatives and alliances that were mentioned in a number of presentations today. But if anything to be thought through or remembered about the AUTI focus at the moment, then it is the topics related to the edge connectivity, edge intelligence, and as well as the edge related architectures that we're focusing on, as I mentioned, in many domains. In this regard, we're already looking at the next step in this thinking and working on the documents related to the so-called guidance for the integration of IoT and edge in data spaces, and the forming task forces on the computing continuums. So for the positioning purposes, how we fit in and what is our focus, I think these are the two angles that I wanted to mention. So what you see on the screen is the paper that was published in March of this year, with great collaboration already. And this is a little bit to your suggestion, Peter, on the how to collaborate together. So this is our example in collaboration with Energy. Specifically on topics related to upskilling, reskilling, and as well as the barriers related to the startups that they've identified within the data share and the building blocks of the marketplaces. And SOE for the topics related to the DSO, TSO collaboration and interfaces. And SDA Bocconi Sustainable Lab, which contributed greatly on the topics related to the regulatory sandboxes and the need for the experimentation. So this work, the outcomes of this work resulted after a number of years of iterations and the previous release. What's been identified in the paper, among many things, is the pathways for marketplaces enablement. And here on the screen, you see some of those and the summaries of. For the purpose of time, I will just focus on one related to the governance, because once again, Peter, you mentioned that that's the area where additional work needs to be done. And here I just quoted directly from the paper. So the type of architectures, of course, very much driven by technology, but as well as market developments and market design. And so the hybridization of the top down and the bottom up probably will be needed with the energy sector. And so in the paper, you can see our position related to that, specifically on that hybrid approach. So we also give our position on the data access and share, federated identity management, topics related to privacy, and also the support services. So unfortunately, I won't have time to go into this. Here, this graphic is also probably not new, because we have it in the vision of the AUTI. Please note that the stage 1 related to the IoT infrastructuralization is the first building block in any of the stages of the development of the marketplaces. And in order to get up there, as you see in the title, scaling up possible only through significant investment in distributed digital infrastructures, and the data spaces. And the clear rules and the favorable environment are key to allow the required financing of these investments. So in the paper, we also propose the facilitation and the rules for this, for the financing of these investments and the related de-risking of the experimentation. Once again, no time to go into the more details, but I would like to leave with you the title of this slide. So the challenges, sorry, I couldn't reduce it to less bullet points than this. A number of those already came up in the previous presentations and discussions. I won't go into the details. So the market design, it's a point here towards the end. The market design is fit to send the appropriate signals to consumers to adopt and engage with these innovations at the edge and at the deep edge will be paramount and important. And so from the technology integration standpoint, this angle we emphasize quite a bit and offer a number of the solutions there. The other topic that probably was already mentioned, but not to the detail, is the public sector participation as the active energy prosumer and also a contributor to foster open energy marketplaces and the not only data, but also the services. So through the smart cities, and I think Martin and your team doing great work in that, but so within the context, not only the smart sector integration, but also smart cities and the engagement of the public sector is very important. And as mentioned by Peter, also the governance is a key for scaling up and the integration. And in the paper, we provide pillars of governance, which is probably linked to the blocks that were mentioned by Alberto as well. So some type of mapping could be interesting. So very quickly, what we proposed in the paper is the further experimentation that is needed to address the three very distinguished layers. What are these layers in the energy sectors? Around actors and the networks, so linked to the energy assets and the infrastructures, the IoT infrastructures linked to the energy assets or becoming energy asset. Also the data and the connectivity layer and coordination and governance. So the governance came up a number of times, but the coordination of governance is also something that we're putting there. So you see the suggestions for this type of experimentation, which is linked to the regulatory sandboxes. Also in the paper, you will find the so-called evolving directions on the reference architectures beyond the scope of the AOTI reference architectures, and also the principles that the fundamental concepts related to those. So just one to mention here is one of the concepts is the decentralized yet federated that we are proposing, and the lots of topics on the so-called twofold governance, where we're suggesting keeping up with the evolving models and technologies such as blockchain and distributed ledger technologies, including their potential to transform and actually change the governance of cities, and ensuring a fair distribution of revenue streams and avoiding the creation of new monopolies. So these two are being advocated in the paper. And so I will stop here. This is just to remind that this is a logical step and the pathway in the work that's been advocated and done before. So this is our starting point, and we see which we shared about 3 years ago, and you see the progress is already being done, but in terms of the reaching golden mile, we're not there yet. So I welcome everyone to comment and reach out to us as to the paper and the principles, and as well looking forward, of course, on the collaboration for this for the integration of IoT and Edge in the data spaces. Thank you. To progress further, now I'm going to put my other hat of the moderator, and I would like to invite Antonella Monti, who's heading the EON Research Center with University of Aachen, to present their position on the new concepts in Edge. Antonella?
I just agree with Pierre that we will swap, if you don't mind, so he will go first.
Oh, absolutely, absolutely. Pierre?
Thank you.
Okay, great. Then I would like to invite Pierre, who is the Chief Technology Officer of Gaiax, to present Gaiax positions on the Edge. Thank you.
Thank you very much. And thank you, Antonella, for accepting to swap our 2 time slot. I have a short presentation about Gaiax, and I do believe that looking at the hearing and looking at the presentation that we had so far, we are very well aligned with what have been shared so far. So the vision is really to share, to have a system where actors like citizen, business, public body, states have a control and assurance on how their data are used. We are working, so the idea here is really to have when we talk about sovereignty, is to be able to be sorry, is to be in charge of what's happening when you share your data, when you exchange them, and how to monetize it.
That's a disadvantage, Pierre. I think you are at your home office, right now. So it's a disadvantage when no one can help with a glass of water in the office.
Yeah, or I run in the kitchen. So it's getting better. So the idea is sovereignty. You keep control of what's happening when you have your data. When we define sovereignty, is really to be able to be in control, to know what's happening when, with who, and why, to which purpose. There is also the idea of to exchange that more than just share the data when you copy and just let the data go. It's the ability to exchange it. So you want to maybe to be able to monetize it through a federated IT system infrastructure. We are working with European actors in order to reuse services and to set up a level of European Commission like IDAS, EBIT, CI, GG Connect, and to ensure also that we have European value embedded inside the core of Gaiax. Transparency, that's being able to know what's happening when, for example, which jurisdiction, non-European extraterritorial law enforcement. That's the ability to learn and see where the information is coming from and how it's used. For that, I will mention also the case that Gaiax want to issue labels. For the security, I believe that it's very critical part of the IoT part and the distributed part. We do have more and more scenario where we talk about federated learning, confidential computing, decentralized consensus, and I do believe that security with zero-based privacy is one of the key success for Gaiax, because that's a hard requirement that's expected from all of the members and non-members also. And the end goal, if I just can rephrase it, it's really to promote the creation of growth of a digital ecosystem for sharing, monetizing data, while ensuring interoperability, security, and transparency. And that's one of the key aspects of Gaiax, and one of the things that we need to have if we want to have truly decentralized, I'm not going to use the word distributed, but really decentralized data economy. And why I'm using decentralized, because there is this notion of that when you have an edge connector, you have the owner of the edge connector that are, you have various owner of the edge nodes. So it's really important to be able to promote a transition from a human governance to a digital governance, where we rely more and more on algorithm and automation. And if I may quote also the OpenDAI, it's really to create a European data economy in a way that you are able to fit European value for self-determination, privacy, transparency, security, and fair competition. So thank you, OpenDAI, for the nice position paper also. Now to focus a bit more on Gaiax. The idea is really to have three main pillars for Gaiax added value. The first one is data asset exchange. We want to be able to keep sovereignty, federated learning, maybe to implement DRM. I know that it's a hot topic, but basically maybe what the movie industry has been doing now for like the last 30 years, there are some good things to reuse and some lesson to learn on how to do it efficiently. Secure computing, you have different way of doing that with a central platform, with a decentralized platform, network isolation, everything that is about keeping sovereignty. To be able to promote digital legal framework, digital signature, digital notary, digital service core banking, to monetize that are also key aspects that you want to have in order to scale. Again, there is this notion of scaling up the data exchange, because yeah, I should have started by that, but basically interoperability, data assets exchange, and service deployment scalability are already there in place. And what we want to do with Gaiax is really to go at another scale and enabling that with a much wider number of, higher number of participants. And I do believe that it's also again very well aligned with this decentralized architecture that the IoT and edge computing case brings. The second pillar is the service deployment. You need to have compliance stack, verifiable credentials that I saw also in the previous presentation. You need to be able to compare self-description, manifest of your services, and you need your services to be discoverable. So you need to be able to promote SMBs. I think this is one of also the key aspects of Gaiax, and one of the success of any type of edge computing. It's if you are able to ease the onboarding of the small participant that will represent kind of autonomous edge case for storing and processing data. And the last pillar is the interoperability. We do have a really strong need, and it's even more important in the case of edge computing, when you need to have service composition. You must have a self-description, so the manifest of your services, I will come back to that, but you need to have also network service composition, infrastructure composition, platform composition. Otherwise, you won't be able to combine things together and really to create that mesh of distributed, decentralized computing. The second point about interoperability, it's really to have a true multi-cloud support. Multi-cloud support, that's not about having one Terraform or Ansible file for the most geek of us and just deploy it everywhere. That's probably not going to work, because people know that you have to write once, run everywhere. It doesn't work very well in cloud. So multi-cloud support requires, first of all, to fix or to find a solution for cross-cloud identity management, cross-cloud access management, and the platform management across different clouds. You can abstract the infrastructure, the platform, the services. You can have, and I will talk about that, a common semantic, but you need also to have a common identity and access management to truly have multi-cloud support. And the final one, final point is that to promote the common semantic, you must share a common language, an ontology, and to provide a common data exchange format if you really want to be able to exchange data from one edge to another. I truly see, so my definition of edge will be everything which is not on premises and out of your direct control. So behind that three main pillar in Gaiax, this is not only just bullet points. I'm going to display now a slide that are shared in the PDF section that I've uploaded. So you will be free to go and check it later. But I want to show that we are really thorough about all the added value, how we split into subpart, what are the key aspects that we need to solve with that, and what are all the possible solutions that we've came across, and there are many more on how to implement that. The next step that we have to do for Gaiax, and that's a bit of selling what we do presentation, it's to prioritize that, that basically turn that mind map into a roadmap. So I don't want to spend a bit more than 10 minutes, so we'll go quickly through my last slide. And basically that's really the how do we see Gaiax being relevant for the edge case. So we have this entire pipeline that, if I display it like that, that's basically what we have in an Hadoop cluster or data warehouse, data lake management for now a few years, decades. But the idea really with Gaiax and enabling edge computing and having really decentralized organization is you have even if in ecosystem you need to have data and infrastructure together, because I don't know anyone having data just flying in the air, and I don't know anyone in the infrastructure waking up in the morning saying I will spawn a database because I like a database. They're both really working together, so I don't want to have data ecosystem or infrastructure ecosystem that make little sense to me. So I really see them together. But in terms of accountability, that can be in the hand of different participants. So you can have a data, the phone holder, for example, and data that is there are two separate type of assets. You can combine that using an algorithm that is maybe provided by someone else. So you might have various entity that split this entire pipeline. So things that we have usually in a Hadoop cluster, Hive, or like ETL pipeline. Imagine that for now, for Edge and for Gaiax, we are able to split that, and each of those cases in that table represent one different entity with one separate cell description. So cell description are manifest that describe basically the characteristic and requirement of the component, and you are able to compose them. To compose them, that's basically what I've said earlier. Here, you need to have service composition, service composition to application composition to make sure that your data or your application runs on top of the hardware. You need to have network composition, and you need to have also something which is not existing so far, but legal agreement or label composition. So to make sure that your data is compatible with the data which is there, and you have the right to use it to the intent you want. So for example, joining two data sets into another one, maybe doing some machine learning, having a model, storing the model in a database, and later you can also do in the inference and publishing that. You can have now, so those are things that we need to know how to do that. The idea to scale and not to have this monolithic silo where we know that in Europe, otherwise we will lose control, is really to enable multiple participants to interact and build this entire pipeline in a decentralized way. This is for me the biggest added value for Gaiax, because it will truly enable people to have this, first of all, data lineage, so the control of what's happening. By default, we need to make sure also that we are in control of who access the data and how the data integrity also of the entire during the workflow. I'm fully aware that it's a big change, a big task, but we are convinced that we are able to do it, and the work is progressing quite well. I'm inviting everyone to also attend the technical deep dive that we have on Wednesday, and we do have also a mailing list. I invite everyone to join if you wish to have any question or ask question, get up to date with the latest Gaiax technical development. Thank you very much for listening.
Thank you so much, Pierre. So avoiding monolithic silos, good one. It's a new term. Looking forward to the next steps and the collaboration. Thank you. So as once again, we'll save the questions for later. I would like to invite Antonello Monti. You've seen the outline of the ASGAM earlier on. So that's the work of RWH, and Antonello is going to share the Platone.
Yeah, it's thank you. It's actually more than using Platone as a cover, but it's actually trying to build a bigger picture around how the grid operation are changing because of the edge. Naturally, start with a project that already ended, but I think was a very important milestone in understanding that the fundamental changes we all discuss about energy sector deals at the end with having more and more data that are required at the edge. And that's where it fits very much with the discussion we are having today. But it's also not fitting with the classical architecture on how grid are run as a typically centralized system with a central control center. So, everything in a monolithic type of thinking from the point of view of function and the point of view of data management. In the project that we had a couple of years ago called Sogno, we started exploring how we can break this original approach and building an interesting synergy also with the 5G infrastructure. 5G will be an opportunity to have edge computing available everywhere, and then represents an interesting opportunity to decentralize the logic of the grid and bring in the intelligence of the grid closer to where the active devices are going to be in the future. In that context, we started developing an idea of a modular approach to platform for grid operation that we call it Sogno platform. Is a microservice-oriented architecture that was developed in that project and tested with a variety of use cases. And what is interesting about the architecture that we discussed at that time is that you can see that depending on the complexity of the grid as a central platform of intelligence, or building a modular approach with replicating the architecture of the message broker. This could be, in some instances, being MQTT, or it can be Kafka, but building then also the possibility of a distributed intelligence. Such a solution is much more coherent with bringing intelligence at the edge, which means smartening the grid also in the medium, but mostly in the low voltage, which means bringing a level of complexity of the grid that moves from dealing, as we had in the past with transmission network operators, dealing with order of thousands of nodes, with a distribution grid of the future dealing with millions of nodes, which is a massive change that requires a massive change also in the architecture. What is interesting is that what was a project on Horizon 2020, because of its value of general standard approach, has been now transposed to a Linux Foundation Energy with the same name, with different logo and a different interpretation of the acronym, just to keep a separation. But that is offering now an opportunity to have a worldwide discussion of what are the services that constitute a microservice architecture for grid automation, and what are the interfaces. So working in a pre-competitive approach to really develop the intelligence that the grid need to think in this different way. But what is critical, it was mentioned several times, and that's one important point, is that even if we build this modular architecture and scalable from the grid perspective of the electricity, we all know, it was mentioned also by Natalie before, we cannot imagine that the electrical grid will make it alone. Here is critical that the architecture opens up the opportunity to bridge across sectors. And when you think about bridging across sector, what we see, and we saw also in that project, in another project later, interesting opportunities given by the possibility to link the same data bus to a fiber concept. Fiber means dealing with the IoT agent and context broker. Context broker is now a European level standard, which allows us to bring the electricity close to the other sectors. So thinking again of the modular architecture shown before, if you think about future use cases across sector, think about e-mobility or also link it to other more exotic way like health type of services, we need a context broker that will allow data mostly related to the electrical vertical to interact with other vertical. First of all, other energy vertical, that's another dimension not to forget, but also other completely different sectors. And that's where the open architecture of fiber, so bringing an open source solution like Sonio that was developed as specific for the electrical grid, together with fiber, which is another open source type initiative to break silos among data, allows us to build a very flexible architectural solution that is ready for the modularity on one hand, but also for the multi-sector on the other hand. What is missing though, the focus I described so far has been mostly, maybe I would say only, on the infrastructure operator. But what we know also that is critical for the future energy system is customer engagement, and how we can bring the customer in the system, make them active players, and at the same time preserving the security and the safety of operation of the grid. I heard during the presentation before, the energy sector is famous to be a little bit slow and not always on top, but we have to consider that the grid operator are managing one of the critical infrastructure, which is a fundamental pillar of our society. So they have to take, a little bit more cautious approach to anything. And that's what I had in the first slide, Platone. That's what we are actually addressing in Platone. How do we enable the grid operator to make this step further? So we have seen a concept of platform from the Sonio project already developed, but there are two elements that in that vision were not at the focus. One was customer involvement, and the second, bringing the customer also to participate to market of any kind. In the project Platone, we are extending the previous vision of the Sonio platform exactly to solve these two questions. And what we are experimenting in the project is the development of a very thin, simple blockchain access layer with the possibility then for the grid operator to use the data from the customer in a very secure way, at the same time enabling the customer data to enter and also be mapped to any kind of market platform with the standard interface. Here to mention that in parallel to the project Platone, there is another project called Universal that was funded in the same call that is really focusing on the interfaces to the market platform so that a unified view from the customer to the grid operator to the market solution can be built and all based on open source software. And again, all those contributors I mentioned so far are committed to fit into the ongoing Sonio project in the Linux Foundation that I mentioned before, so that this open source approach, which is critical for the fast pace, so that energy can somehow catch up. Continue on the comments that were given before, thanks to a fast pace to innovation, thanks to open source. And here you see exactly how these three key elements are brought together. Customer interface to the data bus, thanks to a blockchain interface to the market platform, but also interface to the legacy system. Even if we advocate and see the value and the role of all this edge intelligence, this transition cannot happen in one day for the grid operator. In that respect, we have to imagine that still for a long time, and maybe in parallel, even forever, whatever forever means, classical, more SCADA-oriented system may stay there. That's why, again, for the reasons of security and approach that has to give the continuity of services, the first element, the grid operator may decide to keep still, and for a given time, whatever that is, some of the services that they see more critical, completely managed in a more classical sense. So a completely isolated infrastructure, just dealing, for example, with equipment like protections were required. It's only electrical systems related, doesn't have to get involved in the data type of interchange. At the same time, is fundamental for the system operation. Here you see that concept of platform, here mentioned the DSO technical farm platform, which at the end means the Sonio architecture, is expanded in three directions in creating a solution, which put the DSO at the center as a data exchange, unbiased data exchange that facilitate market operation for the customers, include the customer both in operation and market, and is not forcing, a night to day change in the classical business operation of the grid operator, thanks to the possibility of keeping the legacy systems in the context. And last, I'm trying to be very fast given the time, last element is also same architecture being considered by another project called EdgeFlex. Here, a different principle of virtual power plant is being developed. Virtual power plant are a key element of aggregation, but they are being considered so far mostly a market level TSO, so high level type of requirements. Vice versa, the need for edge intelligence is pushing now the virtual power plant concept to evolve, to become a new type of tools in which we have slow dynamics and fast dynamic services. Fast dynamic services will require more edge intelligence, while the slow dynamic services can be more the classical VPP and bidding on the market. And again, here is where you come to the edge concept. And so the EdgeFlex project is basically expanding the same vision of Sonio platform presented before, with the possibility of services that are related to a virtual power plant. So bringing in the concept of aggregation of virtual power plant into the normal operation and more advanced operation, I would say, for distribution system operator in cooperation, again, with transmission system operator. Yeah, as promised, I try to keep it very short, but to give you an overview on all those pieces that fit together in creating a new view of edge intelligence for grid operator without forgetting also the classical, let's say, way of running the grid. Thank you for your attention. And I give you back to you, Natalie.
Thank you so much, Antonella. You just added an additional level of complexity for our position on the guidance of the integration of the edge, the fast dynamics and the slow dynamic services. Yes, so but it's an excellent distinguishment between the two. Thank you. I would like to invite all of these speakers to join for the panel discussion right now, and for the participants of the workshop to share any questions or suggestions they have. And I think for the discussion topic, Peter has a number of the challenge topics or the questions for the discussions to share with us. So Peter, please feel free to share the screen or to address those. So we have on the panel discussion, Peter, Alberto, Antonello, and Pierre. And I see, yeah, Pierre, I think left. Yes, he unfortunately left, so he's not with us. And since, yes, and if anyone from the second panel also would like to join the discussion as well, please feel free to do so. But I think we're also going to have a little discussion at the end. So Henrik, Kalle, Rafael, Miha, and Fabio, please join us as well. Peter, over to you. Yeah,
well, as I said during my presentation, these are the questions I would like to input for the panel discussion, and reflecting to all the presentations. I was really thinking about we have to compete with China and with the US, and I'm not advocating a one-party system in China. But if you see what the positive aspect is of a one-party system in China, is the party says we go left, then everybody goes left, and they create speed and they create power. Now in Europe we are fortunately not in that situation. But if we have to create speed and some urgency as well, then what are we going to do about it? So it's really about how are we going to approach.
Yes, thank you so much.
And that's my question to the audience.
Mm-hmm. So it's the question of how to optimize in a way that we can proceed faster in spite of potential divergences, and what is this hybrid governance model that could be in place where we really move and then if there is a multi-speed, how to get the rest on board later on. So for the purposes for having the discussion, I would like to go around the panel and maybe solicit the reaction to this question. I think there are two blocks, right? So we will start with this one, and Peter, you will introduce the second one later on. Antonello, can I start with you to reflect on this and share your suggestions?
Yeah, well, I hope, basically gave a pre-answer in my presentation. I think cooperation is critical and cannot be done in the classical way. And that's I becoming more and more active in the supporting the concept of open source to speed up the process, to increase cooperation and make sure that things are compatible, first of all, but also quickly develop because people collaborate. I think the other sectors show the energy sector this is possible. We have to convince the operator in the sector that this is possible also in energy. I think this is the challenge, maybe also somehow responding also to the second question, but it's a challenge we have to take because the speed that can be done with cooperation is incredible.
Okay, so the architectures like being developed in Sonio, for example, you believe that there is a will to accept and not anything necessary in order to speed it up at the moment.
Well, we need in the project right now we have some services, not all. There are a huge number of things that have to be developed and agreed, and also in the data exchange and also bridging to other sectors in data models. Agreeing all those things is only possible if we do it in a transparent way, in an open table like the open source approach allows you to do.
Okay, so I took open source, and yes, there is willingness to go ahead with that. Alberto, thank you so much, Antonella. Alberto, would you like to comment and share your vision?
Yeah, I think that this point about the open source technologies is the most important one because it's really helping in speeding up. And from the other side, we have the well experiences also with the data exchange platforms, for example, in the smart cities that are already advanced well. So we have a good reference also for the energy with all the differences that we have. But the incredible transformations that we are seeing in the energy sector are related to the new role of the customers. And so now we are moving forward in changing also the market models and changing also the energy management to involve more and more the customers. And I think this is what we have also seen, for example, with the Platone project. And going in this direction, we help to speed up more and more the transformation that we all hope.
So uptake is the key, and the engagement is the key for the speed as well, right? So we have to get it right in order to gain that speed. And I think you suggested that the open source is also one of the key components. Thank you, Alberto. Then I would like to go to, so Peter, I think you've shared your position, but maybe if there is something that was left out of the presentation due to the time that you still would like to share with us?
Yeah, one element, I fully agree with data exchange platform and open source, but I think if we want to make speed, and it's not only about content, but it's also about engagement, and not engagement by experts who know a lot of these things, but also engagement from executives, because at the end, companies do what the executives say, what is the direction are. So that would be an advice from me to the European Commission as well, to see how executives in Europe, in companies active in this field could be steered, because that could speed up engagement as well. And the last point is, I was asking Rolf whether there's also somebody from DG Enner in this workshop. Well, that was not completely clear, but I think, as I said in my presentation, the DG of the European Commission should take a much more stronger role in steering the process, and that should be really a collaboration between DG Enner and DG Connect, and then DG Enner could focus in on the specific regulation needed for the energy sector on roles and use cases at certain things. And DG Connect could really focus on the enabling technology which is needed for that. But that would need a very strong cooperation between DG Energy and DG Connect. And maybe Rolf can comment on that as well.
Rolf, would you like to comment? I cannot hear you, and I'm not sure I'm seeing all the cameras on the screen. No. So,
okay.
All right. Thank you so much, Peter. Yes, a lot of topics were mentioned. I will save the comment from our side towards the end of the session. It's because it is really in our paper some of the solutions towards that. But given the time, Peter, would you like to go into the second question as well?
So sorry, I assumed you addressed it as well. That is, yeah, if we really engage, how do we get it organized? And as I suggested, is there willingness? Because if there is willingness, well, then we should get organized ourselves together in a much more cross-sectional way and work on both on use cases as on the technology specifications. So it's mainly about willingness and how that translates into action.
And a lot of on our side right now, in terms of the commitment to the infrastructure investments, as well as you might have seen the news from this morning, that the electricity sector is gonna gain even more relevance since the investments, European investments in gas, just from this morning seems to be diminished significantly. So let's see how it's going to affect the need for the flexibility in the electricity sector. That's the first thing that comes to my mind. We have great organizations or the institutions already in place, such as Bridge, such as Gaiax, IDSA, and AUTI, bringing a lot of the components together. So what else is needed? How to collaborate? So very quick comment from the panelists, if possible. Antonello, can I start with you?
Yeah, well, I think we need to bid on the one that are really willing or ready to move forward quickly. I think if I look at the energy sector, particularly think about grid operator, I can basically distinguish two big categories: the one that are ready to change and the one that are waiting. We should really give advantage to the one that want to move and create some reference case that works and convince the other people to follow. And because there are the one ready to go, and because they are under specific pressure, they realize the problem before. It's not they're smart or whatever. It's really the condition in the country that may change completely the perception of the challenge. But those operators that have ideas, that want to do it, should be helped quickly. And then when we have something running, the other will follow.
Thank you so much, Antonello. Peter, I see you nodding, so there's a consensus in the panel.
I fully agree, and I advise the Commission and sometimes already really build a coalition of the willing, because getting 22 member states to jump through the circle at the same moment is a difficult one. Just start with the coalition of the willing. And
so I think the consensus that not everyone has to be speeding ahead, but as long as there is a coalition of the willing going at the right speed, I think the rest could catch up and still having I see Antonella nodding, that's good. And the earlier statement that we have to compete on the solutions, building the infrastructures and everything behind is really a collective effort. And we do have to have the distributed yet champions on it. Thank you. Alberto, very quick statement from your side.
Yes, I do think that there are also new concepts that are involving more and more all the stakeholders. And I think, for example, about the spread of the local energy communities. So in this way, also convincing the final users will be a great achievement and something that will help to boost what we have to do.
Great, thank you. I see the chat message from Henrik. I think you have the solution for us to keep it simple. Please share what you mean. Henrik?
Yeah, I think I very much agree with what I have seen, that we need to use open standard and use open source and things like that. We're doing that as well. But I still think that there is some conservatism going on and below the discussions here, because it's very much focusing on the power system, and the future energy system will be an integrated energy system. So we need to realize that things like blockchain and so on are difficult when you consider integrated energy systems. So I think I will come back to that in my presentation also. Yes. We will have a I also gave a plenary talk for Siemens worldwide about a month ago, because they want to take the next step in IoT and Edge solution. And because for Siemens, the market is not only Europe; it's the globe. It's global, yes. So we have to keep it rather simple. And I think, for instance, terminologies like markets we need a disruption here. We cannot go on considering ordinary bidding and clearing and so on when you look at the flexibility in a DSO area and a feeder. That's not a viable solution, I think. But I'll come back to how we do it later on. Peter Hermans, which is in our advisory board, knows about it, but it's pretty simple what we're doing, basically.
Okay, so Henrik, prepare the presentation. I'll just wrap up this this session. I see another comment related to the standards. A companion move is to promote the important building blocks to standardization with the help of AOTI, DAIRO, and stand for ICT. So that's another movement, especially if there is a consensus on that. Then what I wanted to, so let's leave it at that for the moment and move to our next session with the presentations. So we have 5 presenters, so we really need to keep it tight, but I understood that we probably infringe a little bit into the part 2 vision and statements. So if you allow
that's I'm going to say, yeah. So we have basically 1 hour left, and we have about the same kind of discussion to go, and all we need is a short wrap up in the ending by me and Svet, and perhaps also Rolf if you have some comments. But so very good. We're kind of on track, but please keep it succinct so that we have these kind of discussions. Also, so that I mean the broad problem statements are quite well known, I think, and they've been covered in many of these. So we should really, I mean, like you also are, drawing towards Henrik. So what is specific to the energy sector, and well, maybe not even just the sector, but the energy situation? That would be really good, so that we can focus on that. Yeah, thanks a lot.
Just wrapping up this first panel and being very concrete. What's missing is the vision where we want to see ourselves with these approaches, maybe in the next 2 years and in the next 5 years, and having the concrete KPIs and the process monitoring to achieving that. So just using as an example of the recently published Hydrogen Act that very clearly states that, what is the roadmap on the capacities and what's the roadmap on the achievements, in the next 5 years, 10 years until 2050. And there are lots of people agreeing and disagreeing, but the roadmap is there for the very well-defined function. So, and then the collaboration wraps around it. So maybe something like this vision for the data and services share and the flexibility services could be worked on within the energy concept, and then the industry gets the signals and the clear directions actually for the ramping up and the scaling up as well. Just an idea. So the vision and the plans. So let's step into the second session of the new concepts. Henrik, floor is yours. Thank you.
Thank you. I think you should be able to see my screen now. I'll be rather practical because in Denmark we passed something like 50% fluctuating renewables, mostly wind powers, a few years ago. And when we approached, I say 40% or something like that, we saw that we needed the disruption of how we operate the energy system. So I'll focus on some of the challenges and solutions which we are looking at in our implementation of the future weather-driven energy system. So even though I come from DTU Compute, which is mathematics and computer science, in my presentation I'll not be very technical. I'll mostly zoom in on some of the challenges and the solutions we have implemented so far. Of course, I guess you more or less all know that in the future weather-driven energy system, the intelligence has to move away from the production side to the consumer side. So all the solutions, the intelligence has to be implemented on the right-hand side here to keep things in balance. We also need to integrate the different energy vectors. That's very important to enable enough flexibility for the future energy system. So some of the challenges we have identified is that people are still thinking about conventional markets where you bid in flexibility, whatever. Of course, when you think about high-level markets, Scandinavian market with Nord Pool and so on, of course that will still be the case. But the challenge is to engage the end user and to unlock the flexibility at the end user level. And on a feeder, a DSO, a small DSO area, we maybe 30, 50 houses, it might not be feasible. At least we don't see how we can do it to create a market for solving voltage problems and congestions in these areas. So we have developed new procedures for how to link, you may say, high-level classical markets, which of course should still exist, to the low-level physics, where you also have problems like congestion and voltage issues and things like that. We also need to ensure that we have a coherency in models. So even though we split the computations and the data handling and so on between the edge, fog, and cloud levels, we need coherency, because the forecast we are doing on a low level should be consistent with the forecast we are doing on the next level, and so on and so on. So this is an area where we have published quite some new, I think, interesting results last few years, where you link the different data handling results on the different levels from edge to cloud in a coherent way. And another thing, which of course many of you know, there are a lot of different service possibilities or challenges which we need to face. Frequency, we need to keep it stable. The voltage has to be within some limits. We need to avoid congestion and things like that. There might be capacity issues, or there are capacity issues sometimes on a transformator and so on. And all these things has to be handled. And of course you could set up markets for all the different elements, but that's, I don't see how this can happen. So that's why we're doing something different. It's also very important, as I also said in the beginning, to introduce, to have an end user engagement. The flexibility has to come from ordinary people, from the industry, from wastewater treatment plant, from whatever. So this is the key, I think. And one thing which I have also not heard today, which I think is a very important aspect, is how to describe flexibility. I think people agree with me that the flexibility has to come from the end user side, a lot of people are talking about flexibilities, but what is flexibility? How do you describe it? How do you describe it mathematically? How do you create bids, for instance, if you should bid that into some markets? Then we have the problem size, because now the data will more stay on the edge. I fully agree on that, but things still have to be linked, and we need to address all these issues. Another thing which has stopped a lot of projects, for instance, one project I have been involved with in Germany, was that people, when they are confronted with rather complicated contracts, they more or less give up, or it was very difficult. So I think we should keep that simple, and similarly for the requirements on what should be installed on the end user levels. So these are some of the challenges we try to deal with in our setup. So what we have developed so far is a smart energy operating system, which the main thinking is thinking across temporal and spatial scales. Of course, you can also think about linking cloud, fog, and edge computing models and data in the same way. And this is another thing is that it should be able to create a link between power systems, thermal systems. We have a lot of, for instance, district heating in Denmark. We are also having a lot of biomass and the gas is going to be green. And all this has to be linked on all different levels and all different time horizons. So one of the key aspects, and we wrote a book about this smart energy system some 4 or 5 years ago, and I don't have so much time here. So, but the key principle is that we, from some level in the system, we simply just broadcast a price, and this price is formed in a way so we are able to solve the problem which the DSO, for instance, are faced with, or the balance responsive party are faced with, and so on and so on. And the same this is a little bit power oriented, and we have similar plots where we had considered the entire energy system, because it's very important to realize that energy systems integration gives a lot of flexibility. We should also realize that, for instance, a wastewater treatment plant, they can be extremely flexible, but they will never let a power company or an aggregator control the wastewater treatment plant, because their main priority is to clean the water and avoid the water in the streets of the city. But the third priority could be to provide services and help the grid. So this is why we are more and more broadcasting from some level prices coming from some middle layer computational problems, where we find the price which solves the problem in balancing for the TSO, for the DSO, and so on. So the characteristics is that we have, as I said at the beginning, we still have, of course, ordinary markets at high levels. Of course, we should have some price levels, but we have more and more data intelligence at the edge level, and still also some on a cloud level, or maybe also fog level, where we do some aggregation. So it's a nested system of systems. But the most important thing maybe here is that on the lower level, we simply just have a broadcasting of prices, a one-way communication system, and we have a setup which is where we have privacy and security by design, because we will never be able to see the private data in real time. The training and so on is done offline and after checking data and things like that. So online, we only have a one-way communication system. It also means that basically we'll have a very simple setup for contracts. In most cases, we don't have any contracts. We just have a time-bearing price. We also, one of the key aspects is also that we have suggested the use of flexibility functions, because if a wastewater treatment plant or a supermarket has been flexible for this half an hour, then it cannot be flexible maybe for the next half an hour. So it has to be a dynamic aspect and not just block bidding. So we are using the concepts of flexibility functions rather than just block bids at the lower level. So this is just an example of 3 buildings, or of the flexibility functions for 3 buildings. This shows we have a step change in prices. how the building control system will react. And this building might have appliances, of course, and it has heating system. And in Denmark, we need heating most of the year. So, for instance, building number 1 is a building with a slow response. That's a building with a water-based heating system, whereas building number 3 is a very fast. These just have electrical heaters, and this one has a heat pump. So this shows different flexibility functions, and they can be used to provide grid services, as shown here, because the different flexibility functions here shows the relationship between the penalty and response. And based on if we formalize the problem of balancing voltage, keeping the voltage in control and frequency and congestion and so on, then we can derive mathematically a penalty generator, so we ensure that everything is in control. And at the same time, we can actually, today we talk very much about energy efficiency, but many of our solutions today focus more on emission efficiency, because the trick is to save CO2, and some of these solutions implies that maybe we save 30%, 40% more CO2. We save 40% CO2, for instance, in one case, but we use maybe 4% more energy. So you should be very careful in distinguishing between emission efficiency and energy efficiency. It has to be balanced in the right way. Also, as I mentioned, the markets, we have to go away from this bidding and clearing, where we have the bids and then the bidding curve and so on, and then we have the equilibrium. It is when we go to the low level, to, for instance, DSO area or feeder, it is a dynamical problem. It's a stochastic problem, and it is also a nonlinear problem. And the way we deal with the different services is we do coordination between the different services, and we establish hierarchies which are consistent, because the frequency is something which are valid for maybe a large synchronic area. We are also doing the same on an island, Faroe Island, for instance, which are very insulated, so then it's a small area. But we need to do the coordination across the different scales. And we also solve the computational problems by moving a lot of the computation to the edge, and in general do decomposition. And we use what I just said about the flexibility functions and one-way communications. So this is something we have implemented in Center Denmark, which is up and running, because now we have passed 50% fluctuating renewables, and we don't have hydropower to balancing. So it's the digital energy solutions are extremely important for Denmark. So we have also, and of course I could have spent a lot of time on how we do the data exchange. We have a trusted data sharing environment, which is not only data but also software. We connect the country but also out of the country. This is the control room, and the most important thing is we have this spatio-temporal thinking in the way we build the control room, which is the same we have in our operating system. So I think I'll stop here. We have in our solutions demonstrated a lot of flexibility, but we need to consider systems for the world. Yeah, I'm running out of time, so thanks a lot.
Indeed. Thank you so much, Henrik. Lots of additional dimensions introduced on the heterogeneous approach of the participation and the flexibility and the issues with the markets design or the challenges out there. So to be continued, I would like to give the floor to Kalle Cook. There is a lot of work is going on in Bridge, and Kalle is chairing working group on data and affiliated with Ellering, who's I think if we use the language used before, is one of the leaders or the drivers of the new solutions in the market. So Kalle, floor is yours. Thanks. Stay with us, Henrik, please, for the discussion. Kalle, we cannot hear you. I see the screen, but I cannot hear you.
Thank you. Can you hear me now?
Yes.
Yes, we hear you.
Perfect.
Okay, thank you for unmuting me, because I couldn't, after starting to share, I couldn't go back to unmute myself.
Great.
Anyway, I go, and you can see my slides as well. Okay, good. So thank you for asking us as Bridge here. I only could hear the previous presentation and had to leave right after my presentation. I see we are behind the schedule. Anyway, as said, I'm representing Gaiax, which is the Estonian TSO for electricity and gas, but here I'm mostly to present the recent findings of the Bridge initiative for cross-border and cross-sector energy data exchange. So just to inform some of you what is the Bridge really shortly, it's just the kind of cooperation platform initiated by the European Commission for the Horizon 2020 financed projects in the fields of smart grids, energy storage, islands, and digitalization. And here is some types of, let's say, fields addressed by those different projects. And the technology is there, which is very much about the ICT technologies. And this is where our focus was in this recent report. So to the topic, we worked last year on the European Energy Data Exchange reference architecture. Even though it entails the word energy, we had in focus also the cross-sector, so the beyond energy interoperability. And we made some recommendations there, which I will briefly explain in my presentation. And as I said, it should ensure the free flow of data, respecting the data privacy, cross-sector and cross-border. So it's not so common in the energy sector yet. I guess also not so common in many other sectors yet. So this is basically the outcome of this work we completed. Obviously not able to explain all the details, but just a few messages. So we based our work on the SCAM model, the smart grid architecture model, in order just to frame our approach somehow. And this model it's a three-dimension model, but we see only one dimension here, which is so-called layer dimension, and you see 5 layers here: business, function, and further down. And we split those layers further into some sub-layers where we thought it's useful and relevant. And for each sub-layer, then we, based on the Horizon project's input participating here, we identified some examples here, like you see on the regulation sub-layer, clean energy package, obviously something very relevant for us, or for the information models sub-layer, the SIM or COSEM models are something which most of the projects are following. And then on the other side, we try to look for the experiences from the other sectors. We contacted few, we got only feedback from one, which is the ICT for Water Association. So for water sector, we got some insights into their activities. And then in the middle, what we call cross-sector domain are the elements which we think are common for any sector, or at least should be common or could be common for any sector. And if you look what is there, it's all about the data. It's obviously on the information and communication layers, it's all about the data, but also in the business and function layers, it's all about the data. So in the business layer, for example, we have listed business processes like data governance or big data. And in the function layer, functional processes like consent management or management of data logs, etc. So if you look at these, you can imagine these are quite generic in the sense that they could be applicable to any sector. And why it's important then that, so if we define a business process like that, or functional like that, or data model like that, then we can more easily bring the different sectors together more specifically the different stakeholders and different systems of different sectors together, and it's easier for them to start to talk the same language. And on the most right side, there are some recommendations made in this report based on the on this model or architecture. And in the following slides, I briefly go through those recommendations. Here they are just short names for these, but you see that basically for each sub-layer we have made recommendations. Some general ones. So I think it was proven that following the smart grid architecture model approach, it is useful, and it's something that of course can be applied for any sector. The regulation for cross-sector data exchange, something to be kept in mind, and we already had initiatives like for data spaces or data interoperability implementing acts, even though the latter is for energy now. But I think the way we can make the data easily available via these principles can also serve the other sectors. And of course, the cooperation between the different stakeholders, which is not so easy at all. Then the following set is about the processes and solutions. So as I said, it seems like quite easy, but I think it's a kind of starting point to start with defining and then harmonizing the data exchange business use cases, which we can have in common across sectors. And the same for functional data processes, which we define in the system use cases normally. And a point on the data exchange platform. So it's to be recognized that data exchange platforms is one kind of solutions only. There could be other solutions, like quite often people in our sector refer to simply bilateral data exchanges based on open standards. But this study was focusing on the platforms. So we say that there should be, and we recognize there is a variety of platforms. And we say that connecting to those platforms should be first, of course, easy, but also that if you connect to any platform in Europe, you should reach out to any other platform across Europe. So you as a data user or data provider should avoid the requirement of connecting very many different platforms. And still, even though talking platforms, it should work for other kinds of solutions as well. We recognize those other solutions, so we need the interoperability between any kind of solutions. And we can also develop data applications, for example, for big data, which of course can serve any domain. So here about the information and communication layers. First, canonical data models and ontologies. So we quite widely use CIM, Common Information Model, in energy sector and more widely, I think. But why not to either extend it to other sectors or at least to make it interoperable with the similar kind of canonical models of other sectors. Also, quite the same story, data models and profiles. So the data semantics, it can be quite easily common, I think, but still we work in silos. Regarding communication protocols and data formats, we say, and we acknowledge that there can be several of them, and therefore we should try to look for approaches which are agnostic to specific protocols and data formats. Then the other set of recommendations relates to the roles. So we have identified many new roles in those Horizon projects. And we, of course, focused on the more what we call data roles. So, for example, data exchange platform operator or data hub operator or authentication service provider. So we identified many of those new roles, and we recommend them to be included in so-called harmonized electricity market role model, which is quite widely used in the energy sector. But then we say that we should go beyond maybe it should not be just the electricity role model, but more like harmonized energy role model, or even more look for cross-sector approach. So to include those cross-sector roles. In fact, the roles I mentioned before, they are of cross-sector nature. And then we should have a easily accessible repository for those roles. And final set of recommendations relates to the SIM itself, so the common information model again. We recommended to set up a SIM repository, so at least all the bridge projects can easily access and follow, but it should, in our minds, to be extended beyond Horizon projects as well. Also, we suggest to set up a European SIM user group. There are other user groups, but really like European, to represent the European interests, and maybe even going more beyond SIM, talk something like smart grid standards user group. Very relevant items are dissemination and education about the SIM, and also to make those SIM UML models and associate profiles available. So this finishes my presentations. Thank you very much. It was quite a generic, but I think we should, it's to be reminded that we should not forget any of those pieces or sub-layers, as we called it. Thank you very much.
Great. Thank you so much, Kalle. Actually, quite detailed recommendations, so they will stay with us, and we'll see how to still answer and address the questions that Peter had to us at the beginning. Thank you. I would like to give the floor to Rafael Rodriguez, with EDP, grid operator in distribution grid operator in Portugal, and just ask if we can go directly into the recommendations that the rest of the speakers prepared. We have 3 more speakers, so please stay within the 5 minutes time frame, and I will switch the camera on. When you see the camera going on, then it's a sign that
okay.
Thank you.
Hope you can hear me and see my screen.
Yes to both.
Okay, thank you for having me here today. I'm Rafael Rodriguez, as you said. My presentation will be brief and is separated in only 3 parts. I will start by presenting, doing a quick overview of EDP New. EDP New is an R&D center from the Portuguese utility EDP. New is responsible for doing applied R&D focus on the energy sectors and tries to create new opportunities during the energy transition. New is also the reference inside the group for European projects. We work in close proximity with EDP LabWEC, since we are located in the same facilities. Inside the LabWEC exists state-of-the-art labs in electrical, chemical, and even environmental areas. EDP and New use these labs capabilities to test apps for demonstration and validation purpose, not only in lower TRL such as 4, but also in higher before going to demonstrations in the field. Inside we can test smart meters, PV systems, smart grid technologies, and even battery technologies. Our researchers work in multidisciplinary teams, but for organization purpose, we are divided in 5 knowledge areas. I'm currently working in 2 of these areas that are relevant for today's workshop. The first one is smart energy systems, where we approach interoperability, smart and microgrids, and also demand response and vehicle-to-grid topics. The other area that I'm currently working on is the new area that we created, which is digital energy. And in this digital energy area, we work on IoT, 5G, and edge computing topics. As it's possible to observe, we have already more than 30 projects, and most of them under the H2020 program. Now, moving to the second part, I will do a brief highlight of some of the projects that we are working on. Starting by the InNeuron project. The objective of this project is to develop innovative tools for the optimal design and operation of local energy communities, integrating distributed energy resource, and provide sector coupling using multiple energy carriers, such as water, heat, hydrogen, and of course, electricity. InNeuron has 17 participants from 8 countries and started in last November. The Portuguese pilot is located in a large military campus at Lisbon Naval Base. In this campus, we are trying to use a multi-hub aggregation system that will be managing micro energy hubs, aggregating energy and flexibility from local demand response coming from industrial and residential loads inside of the campus. Also comprise a 1 megawatt PV system used for local energy consumption and flexibility, and also peer-to-peer trading with other buildings. In this pilot, we are also using smart meters to create a consumption forecast model and use dynamic measures to increase energy efficient. Moving to the interconnect project that was already being presented earlier in this webinar. Interconnect project is a big European project with more than 50 partners from 11 countries and started in October 2019. It has 7 large-scale pilots across Europe, and interconnect brings efficient energy management within the reach of the end users, allowing the digitalization of homes, buildings, and electrical grids based on IoT architecture. The Portuguese pilot was divided in 2 types of consumers, the residential and commercial. For the residential part, Enredes, our DSO, will lead the demonstration, where the initial phase we are going to use lab-like facilities that I previously showed you to do in-lab simulation of an end-user house. In the lab, with real appliances that we are going to use in the field, these appliances are going to be treated as the edge device, and we will try to connect them to the home energy management system. The end goal is to provide energy efficiency and also to provide demand-side flexibility. Moving to the other part of the pilot is the commercial pilot with a customer-centric point of view, where demand-side flexibility aggregation is explored, along with e-mobility, and also convenient smart charging. My time is running out. Just to conclude with the last project, which is 5G as a service project, which started last October as a duration of 2.5 years. The 5G project will develop a decentralized marketplace for the telecom ecosystem. This new platform uses blockchain technology and will be able to connect the whole 5G value chain, from mobile network operators, site owners, system integrators, and hardware and software vendors. The ADP role is divided into areas. First area from the ADP DSO again. The scope of them is to be a neutral host, where the telecom operator can install the much needed 5G equipment that will help the connectivity of the edge. The second row inside the ADP new, in cooperation with UbiWare, we are looking for the blockchain use using smart contracts and NFTs in an overall by using splittable NFTs for the 5G spectrum, which is available. To conclude, the previous projects are still ongoing and the results are not final. Our future will be more digital, for sure, decentralized, and hopefully decarbonized. I'm happy to answer all your questions in the end.
Thank you, Rafael.
Yes, you can find me at this email. Thank you.
Thanks. So maybe in conclusions, you can mention the points related to the mid-agenda for the IoT. Since there are so many projects, so the conclusions and directions would be interesting to understand. So thank you, Rafael. I would like to give floor to Miha Smolinkar from Consensus. Miha, I think you're gonna zoom in and share some insights with us related to the Platoon project. Not Platone, but Platoon with double E and a different logo out there.
Yeah, this is correct. Thank you, Natalie, for this introduction. Can you confirm to see my screen?
Yes, I see a screen. You can go to the presentation mode.
Good.
Here I will disappear, and within the 5 minutes I'll switch to them.
Sure, I'll try to do within 5. Well, good afternoon, everyone. It's a pleasure to be here. As Natalie has said, so I'm coming from Consensus, but my ambition for today is to present the Edge Cloud Framework activities that we are running within the Platoon project, in essence, to actually decentralize the intelligence or the services that we are building for various use cases. Okay, so the Platoon project is one of the 4 projects within the funded within the topic on the big data solutions for energy, with 20 partners and 7 pilots from 9 countries. It started on 1st of January 2020, so we are somewhere in the middle of the project just now. And actually what we are doing is actually to try to address the climate policy objectives with the following 3 pillars. So one is the interoperability, so to enable the data exchange across the value chains. Then to provide the data governance and security framework to actually address the data sovereignty challenges that we have, especially in the aspect of so the going beyond the electricity to the cross sector, and obviously the data analytics toolbox and the edge computing, which is the objective that I want to highlight within this presentation. So going directly into the edge aspects of the Platoon project. So just to mention, so there are different people may have different concepts when we speak about edge. So it may be multi-access edge computing, which is more from the telco domain. It may be to have some edge computing on premise, so in a private setting and in the secure domain, or which is, I think, the great part of the thing that we should be discussing is the smart edge devices, allowing the interoperability of protocol systems or allowing the brownfield applications to be instantiated and integrated with other systems. So in other words, so numerous possibilities for the design of the gateway. So with this in mind, so there may be different motivations to actually go for the edge. So that may be, as we have discussed before, offloading the raw data, pre-processing, offloading the network, actually addressing the privacy preservation needs of certain application, or allowing for certain applications to actually meet the latency requirements and to have the real-time response, or to make particular parts of the infrastructure that we are integrated being able to run in an autonomous manner. And with this broad set of actually motivations and concepts that we can take into account, so there are also for sure many associated challenges. Mainly, I would say, is the diversity of environments that we are integrating, the new challenges related to the scalability of the solutions, the provisioning of the connectivity, and even greater so threats from the security perspective, as if we start to decentralize all the infrastructure, moving it towards the edge, towards the execution elements. So that means that this actually inherently brings in the new threat vectors from the security perspective. And different combinations of these aspects are also reflected in the different pilots that we have in the Platoon project, which are also from different applications. So like there is some asset management, it is the predictive maintenance, and there are also market and building associated use cases that we have in the pilots. And putting it all together, actually, we have found out that, I mean, obviously, constituting the edge cloud computing framework actually for different use cases requires different instantiation of particular services at different sites, so be it edge or cloud, and for different purposes. And all this needs to be actually complemented with the management framework to allow for the management of nodes, the management of the services that these computing nodes are hosting, the management of the actual equipment, especially in the sense of the new computing devices we are introducing in the edge, and to actually orchestrate everything and to be able to actually, during the lifetime of the infrastructure, to allow for the reconfiguration and instantiation of new services. So with this framework, so we are going towards the supporting different instantiation scenarios for like fully distributed control of the applications, and then on the contrary, decentralized control, and also the hybrid or the aggregated control as we have it. And in this respect, we have actually put together these high-level architectures that have different layers from the field, then the edge, the aggregation, and the central part. I don't want to go into details about that, but would rather present you just one example that we have implemented. It's actually a edge cloud computing framework for real-time fault detection, classification, and localization in the distribution segment of the grid. So speaking about the applications that we very well know from the domain of the TSO, but applying it to the distribution grids. So this brings additional challenges, and this is why we went and actually instantiated a distributed architecture from the edge to the central layer in order to support efficient operation of this application. And again, not going into details, but just mention you actually the context of this application and why we actually had a very successful utilization of the edges, because we are making the measurements on the 20 millisecond basis. We are capturing events that are happening on the seconds basis, and these events are occurring actually on a monthly basis. So very sparse events that we are detecting on a very granular data. So this is one example that very explicitly tries to highlight why the edge and the cloud and the distribution of the functionalities among them can be a very efficient mean of implementation. And just instead of conclusions, I want to share with you the vision. So based on all the requirements that we have for the management of the edge cloud framework related to nodes management, the privileges management, so who may do what with the infrastructure, and to orchestrate actually decoupled services, and even to be able to migrate the services over the lifetime of the applications. So there are certain features that we are implementing in order for this to be able to instantiate. So one is actually to allow for the solution to be hosted on a arbitrary edge hardware, well, with the Linux operating system, to allow for the zero-touch provisioning. So that means automatically programming and configuring devices when put on the field, and to embed the security by design with the hardware root of trust, and to support the agents to connect over the VPN. So this has been in brief on the activities of the Platoon project on the Edge Cloud Computing framework in order to instantiate the analytics-driven services on top of the vast amount of data that we are gathering in the domain of energy. So thanks for your attention, and for any further comments or discussions, I'm available on the email.
Thank you so much, Miha, for sharing the work on the Edge Cloud Computing framework. Very relevant and timely, and hopefully will trickle into other ongoing projects looking at that. I see. So I would like to invite Fabio Coelho from Ineshktech in Portugal to briefly share with us the suggestions and the frameworks from their side, also linked to the Interconnect project. So we don't need the introduction, Fabio. So if you can share the new concepts. Thank you.
Okay, so good afternoon to everybody. I would like to thank first on behalf of Ineshktech and the coordination of Interconnect the possibility to be here during this workshop. I will try to be very brief. The Interconnect is actually a flagship project of the European Commission, and for us it's a great honor to coordinate it. It's an actual project that has just under 50 partners that span from the industry, from academia, from R&D institutions. So we have a lot of leverage from all of these important pillars and stakeholders within the project. Okay, we'll have demonstrations in with pilots across 7 European countries. Okay, so that's the dimension of Interconnect. And as I said, we want to leverage here from the possibility of R&D associations, the distributing system operators, retailers, and the role of the end users. Okay, here to sponsor some of our use cases. Okay, Interconnect was born here from the premise that we want to provide here semantic interoperability functionalities. Okay, here motivated by these ATSI and the SAREF ontology as a central pivot to the project. And with this, the role for Interconnect is to provide the visibility to provide grid support services, but also to provide non-energy services on the role of businesses, retails, fleet management, and all of these capabilities. On the focus of that we are providing here SAREF-enabled services and devices, and to make them interoperable under what Interconnect calls the semantic interoperability framework of the project. Okay, so I want to be very brief, and I will go straight to the point to say that the premise of Interconnect is to focus on what we already have as the basis for some reference architectures and open source possibilities to have SAREF-enabled applications on the market. For example, on the side of EVAs and their proprietary protocols of spine that they export, and leverage on that, but also to bring on the rest of the market, the rest of other reference architectures that do not necessarily touch these ontological capability and semantic expression, to provide here in our framework the capability to adapt towards SAREF, to adapt towards this reference ontology, and then to sponsor this interoperability of services based on that. Okay, so very briefly, the role and the architecture of interconnect is kind of based on the idea that while we are focusing on IoT, while we are focusing on capturing data that comes from these IoT devices, in the end, these IoT devices and use cases are wrapped up on the concept of digital platforms, on the concept of digital services that use that data to leverage and to perform the actual use cases. So the focus of interconnect is to focus on the service level and to provide this capability for these services that exchange data, that put data on the central point of their actions to become interoperable, and to provide an ecosystem of interoperable SAREF-enabled services that then leverage the devices. So kind of the motto for interconnect is to provide digital platforms and services to become semantic interoperable, while exposing and leveraging from the semantic interoperability framework that interconnect is designing and deploying. And this is important here to try to provide here from the IoT perspective, how can this be leveraged and what it will unfold, okay? So interconnect is trying to fulfill here a design architecture where we have digital platforms and services that are then based on semantic data exchange, and that will provide this difference between these deployments on cloud fog for digital platforms and services, but also leveraging the capability to use multiple reference architectures. So we don't want to make sure that everyone is accommodating a single instance, a single digital platform, a single platform for data exchange, but rather to provide the ability for different digital platforms and different services from different reference architectures here in this slide, depicted from the example on the left of having a platform that is based, for example, from the Web of Things architecture and standards, and the right on the eBus spine protocol that already provides some capabilities on SAREF to exchange data, okay, and to provide here a basis so that this can become a wide open ecosystem for us to deploy these use cases and deploy these functionalities. The project in itself is, of course, deploying an open call for other projects, okay? And so this is why very important, not only for us to be able to demonstrate what are the capabilities of the project, of course, within our demonstrators, within the expertise and the knowledge of our almost 50 partner consortium, but also beyond that, okay? And to provide this testing capability for others that want to join us under this task and want to provide a use case under our scenario, okay? So coming up to the demonstrations very briefly, as I said, Interconnect is a large project. It's just a large project that is funded by the DG Connect and DG Anders, so touching some of the things that were also discussed on the need for these two Director Generals to come together and to try to accommodate some new regulations and initiatives on the ICT front. So Interconnect is also I don't want to say the first, but possibly one of the largest initiatives on where this is coming, and we want to demonstrate this across our 7 large pilots. Our pilots will reach more than 2,600 households within whole Europe, and the idea is that we want to provide this ability to provide interoperable data exchange on the semantic front, provided and on the basis of SAREF, but not necessarily enforce a total architecture reconfiguration. So our focus is on interoperability, and while providing different views, becoming interoperable, and providing this common ground to test some cross-border use cases here. I wanted here, I put it in kind of this slide to go into the detail of the Portuguese simplified pilot map, but I guess that we are in a rush. The point here was just to state that while we are providing the semantic interoperability framework, we want to make it in a federated way, not only from the perspective of data management, but also from the perspective of data security. And so from the devices on a device level to fog and middleware layers where we accommodate the digital platforms of our partners, we want to provide this verticality on how we can provide these capabilities and to deploy it on the field. So I see that Natalie's on the image now. So I'll come up to my last slide, which is a little bit focused on the takeaways. It's kind of the motto for this. So Interconnect wants to provide here these SAREF-enabled data services, and while doing this, to deliver this digital marketplace and ecosystem of interoperable services. So we want to provide here a basis for others to build on, okay? So to compose on services and on basic functionalities that will be provided from the DSOs to service manufacturers, to appliances, and also from digital stakeholders that we do have on our consortium, okay? So federated data exchange, federated security enforcement is kind of the key motivators for interconnect on the provision of this digital marketplace. And of course, that our large-scale demonstrators will provide the basis for this. And if you or some of our institutions are interested on getting funding from our cascading funding calls, please go to our website and apply. They will start later on this year. Okay. So I hope that this presentation was interesting, and of course I'm happy to answer some questions. And feel free to email us at the Interconnect email. Thanks.
Thank you so much for the insights, Fabio, on the projects and also some recommendations. So I would like to ask Martin as to how we're doing with time and whether there is any time for discussion. Peter left us, so he's not on the call anymore. And since there is still need for the vision statements and the wrap up, it would be good also to hear from Rolf. So I'm not sure if you'd like to optimally manage that.
I think we should wrap up rather soon, but still I think it would be good to give all the speakers in the second panel, you know, just a final thought. I mean, so many of the questions have been posed already. I think actually there's, while there's a richness to what has been presented, there's also clearly something standing out. So like, I mean, the demand side comes quite clearly. The architecture becomes, you know, not one, but what is in common. So what we have seen from Peter and throughout down to the concrete, I think aligns very well. So maybe it's enough for the moment to just offer to those who are with us from the second panel for a quick reflection, and then we'll give the floor back to Svet to wrap up. I have just very, very small thing to give in the end. Would that be right?
Great. Yes. Thank you, Martin, for a couple more moments. So I think two key questions raised by Peter for the discussion is how to collaborate. That point one, and what are the optimal ways across Europe and how to make it faster. So if Henrik, I think you were commenting on this before. After this presentation, any further reflections?
Yeah, but for me, this has been very, very interesting, and I have learned a lot from all these presentations. What I really appreciate is also the focus in Europe on open source, Linux Foundation, and but still do it in a way so we ensure that we have a stable, robust power system and so on. So I think it's yeah. I learned a lot, so thanks a lot. But I also think we still have a way to go, and maybe if we can maybe find some platform projects to really demonstrate large-scale solutions in Europe, that would be great.
Thank you, Henrik. Indeed, agree that we still have way to go. Kalle is not with us. I think he had to leave already. Rafael, so you presented the snaps of the project, but maybe you can share with us the concrete suggestions.
Yes, our projects are still ongoing, so we don't have the demonstration sites already done, but the way forward will be in collaboration, and also integration new open standards. And I think Interconnect is doing a good job, and is a flagship project that will be important for the future for us to build on top. Thank you.
Yes, and hopefully open markets as well. Micha, I will revert to you with the comments.
Yeah, thanks. I mean, I agree with all the comments that have been said, and would like to strengthen this importance of like complementing the open source activities and the reference implementations with the replications in the pilots and the contribution to standards, because we've been listening today that the transformation of the energy sector may be slower than some other sectors, but I think that there are lots of similarities with, for instance, the cloud computing sector or the mobile network sector, where they are going rather fast through the iterations of the generations. And there are not only de facto standards that we put together by the standardization bodies, but it's also the reference implementations that kind of end up in the standards which we want to adopt. So I think this is an important thing that we need to follow to actually build on the developments and try to replicate with the end users these results.
Thank you, Miha. And now to Fabio.
So throughout the workshop today, I've heard talking about interoperability, the need for going away from industry silos on data management, on the need for us to come together and enforce this common strategy. I also heard the Interconnect project being stated throughout all of the presentations as this flagship project and in importance, and I'm glad to hear that. I believe that Interconnect in particularly is leveraging some of these things and in towards what is the strategy to ease out and to make these developments faster into the industry. I do believe that this strategy that the Commission has brought into these large-scale projects in large-scale demonstrators is definitely a very good playground for us from research and industry to come up with new solutions to try to test them under real industry and under real world scenarios, and to use these results as kind of the motto and the Kickstarter for then the industry to accommodate these changes. There is also the need to sponsor and to kind of bring it faster on the regulatory part. Particularly the energy sector is highly regulated. Of course, we don't want to lose the safety of the system, but these the mix between innovation, these demonstrations and the real large deployments and projects, and then what is the compromise and the changes that need to happen on the regulatory field to make these developments a real world development on the upcoming years is where I think that we need to strengthen our position and to sponsor these. To use these projects as kind of these playgrounds and demonstrators to use and to collect the good takeaways and to do deployment on the field and the real world scenarios. So there is where I think that we should enforce and strengthen our position.
Thanks, Fabio. And maybe in this real world tests bed and the implementations, we also have to have the KPIs on the ability to integrate new players in the market, the ease of such integrations, the speed of such integrations, both the technological burden and as well as the economic burden, and have given the fact that we're investing in these systems trying to achieve interoperability and speed. So we should have the KPIs as to how we can grow these ecosystems and the clear way forward and the vision what we're trying to achieve. So it's not only implementation for the scale up, but also the inclusive implementation and ability to create additional economic value around it. So thank you for this intervention, and I would like to thank all the panelists for great discussions. I also learned a lot, and welcome the follow-up on some of these topics and the collaborations. So I'm not sure if we're gonna reach the suggestion of Peter of having the alliance of alliances, but definitely close collaboration on these topics would be much needed and appreciated. Speed is of essence. So thank you so much, and I would like to hand over to Martin for the rest of the session. Thank you.
Thank you so much, Natalie, and thank you everyone for excellent discussion, and thank you also for the moderation here, Natalie, and not only keeping time, but certainly also keeping the red thread going together. Allow me to just, put two things here on the table. Of course, we are looking very much on, you know, the maturity and investment spectrum here, and what we're addressing is also, I mean, how can we get fast from these new ideas, which are sometimes new, sometimes just not yet implemented for various reasons, and we are looking now into a new series of instruments specifically on the European level. And then there's everything around. We talk about open source ecosystems and so on, and lots of actors. Rolf mentioned in the chat also. So what if some private platform actor actually implements something in, you know, the home faster than any initiative can do? I mean, how do you compete with just raw capital? So it's indeed very, very interesting times, but also timely with the new programs. So the timeline here is we are coming towards the end, let's say, of the consolidation of the many strategic initiatives. So we'll put out a preliminary white paper and eventually the roadmap for IoT research, innovation, deployment to inform the upcoming activities. And we still need your input. So we will continue to do that together with the colleagues in EU-IoT, in OpenDI, and well, all the stakeholders out there. So that's it from my side. Svet, do you want to give some final remarks for the colleagues?
Yes, I will maybe try to summarize what we heard today. From my impression, and of course from my work in the area for so many years, energy has been, as I said in my presentation, digitalized already for quite a lot of years. It's what is new now is this paradigm shift from cloud to edge to fog to far edge to whatever you call it, continuum, this decentralization, which is happening. The important things that were mentioned were things such as interoperability and openness, i.e. the vendor and protocol agnostic systems, moving away from silos. It was already, from the presentation, it became clear that most of the standards are there, and they will be applicable also in the edge scenario or the continuum scenario, going all the way to the edge. They probably need some federating and adjustment, but they're valid. There were people have been thinking about reference and creating reference implementation as architectures, which are again applicable or adaptable to a new situation. When we talk about interoperability, on one side, there is the semantic ontology interoperability with protocols such as SARF and others that were mentioned, data models. There was, of course, a lot of talk about platforms, and it's clear that it's not the platform, it's a multi-platform scenario with a multi-cloud scenario in which they will be interworking with each other, exchanging data with each other, etc. Cross-sector, cross-border, and we see that the good thing is that the energy sector is aware that they're not a standalone sector, so it's not only about the silos within the sector of, say, electricity, but also within the whole energy and within the whole world and ecosystem with the other verticals. We see a lot of move towards modularity, so using building blocks. I mean, even in the things like Gaiax, they're talking about, you know, being able to use these building blocks to build what you want. A lot of, as I said, the new thing is federating cloud, edge, service, etc. This is the new thing, the new word. The importance of open source was mentioned many times through speeches. Security is also of paramount importance. Everybody thinks that there should be some kind of marketplace where everything can be found. We need, obviously, infrastructure, which will be cloud edge, such as Gaiax and others that will be provided. Now, this thing about the third generation smart meters that were mentioned, I mean, because the infrastructure goes all the way, it's a bit troubling because we haven't, for so many years, decades, I don't know, we're trying to roll out smart meters, we are nowhere, and now all of a sudden, this is obsolete, we start another generation of smart meters. Maybe the approach is not correct. We have to see how this can be done. There was a lot of talk about use cases. We can't build anything if we don't know what we'll be doing. So the use cases are important, but the good news is that, first of all, there were existing some of them before. When creating all these things like SARF, etc., but all the other projects from what I see, they have been doing this, and they exist in the standards or specifications as well. but we need, of course, to describe the new ones that are coming with the edge capabilities and the services that will be rolled out. There was a lot of talk about the governance, and this needs to be organized. And if you look at things like the data space, for example, that we have foreseen on a EU level, governance is one of the important components that we are looking at. There was the need for vision was also highlighted, where we are going, to be clear, kind of roadmap. It was interesting to hear that what we all know, but we have to be conscious of, that there is always a trade-off when we're trying to achieve different goals, such as like greenhouse gas emissions reduction and energy efficiency. Maybe we can decrease the efficiency in one and achieve a lot in the other, way more in the other. We saw that the major stakeholder platforms, etc., I mean, IoT and the others are supporting this movement, are conscious, aware, and are working on this topic. There was a lot of need for collaboration throughout the whole event and alliances of alliances, etc. So this was highlighted. Not clear how we're going to do it, but there is the intention, there are the ideas that will be put together. And we have the history of collaborating on other previous problems, etc. So we should be able to solve it. And of course, there was a call for EU support for funding and legislation, whereas not only Connect, but the other DGs should be active, was that. Now, from what I showed you, we are already thinking and providing, I've prepared some funding and legislation. So we are working in this direction. There will be more coming. We're going to work together on this. There was also, of course, desire of everybody to move through all the other stages, move to market. And there, of course, I can come back to the graph of Martin that was showing all the way from ideas going to the market deployment, mass market deployment. So I think these are the things that I kind of gathered from today's event that summarize it. I don't think it's a completely new way of approaching the problem. We have had problems in the past, and I think that the way it was proposed for this kind of problem is similar to what we have done in the past. We have succeeded in many of them, so I'm fairly confident we can do it here as well. And the desire is there, all the right stakeholders around the table. I think we are moving in that direction. Maybe now the vision and the roadmap should be written down, and we go ahead. That was it.
Thank you so much, Svet. So what you're saying is now we just need to finish our work, and we are very happy to do so. So I think that's a good thing to end on and here. Okay. Anything else from your side? Anything regarding the Commission next steps? I mean, we will have events all the time. We heard about. I mean, there are several events tomorrow. And you know, in the coming weeks, there's a frenzy. There's 2 work programs coming up, the Horizon Europe, Digital Europe program, as well as the CEF2 and so much. So actually, I think there is instruments enough. So probably it's a good thing that we actually get people from the various initiatives actually working together. So happy again to also be doing this together with the alliances, the Alliance for IoT Innovation, OpenDI, EU-IoT, and Bridge, and so on. So thank you very much for being here. Any final words, Svet, from your side or the Commission?
Just to thank everybody for having participated, having shared their opinion, and supporting the common move towards interoperability, success for European industries, richer services, reduction of achievements of the Green Deal's objectives, and so on. So.
Very good. So thanks a lot. And for those who want more, not of the same, but of something similar in this T-shaped world of digital transformation, we have the health and care session starting in 3 quarters from now. So thanks a lot, and thanks to the team, to the presenters, the co-organizers, the Commission, and everyone. See you soon. Bye-bye.
Bye.
Thank you. Bye-bye.
Many thanks.
Thank you.